All right, so I'm assuming everyone's here for the Shiny dashboarding workshop. The conference schedule has a requirements.txt. I sort of blew it up in the last month or so. So there's more packages to install. I've also modified, like the content's not disappearing, but I also understand that this is the second day, the last session after lunch. There's gonna be a period where I'm just gonna talk at you. You're not gonna be, if you want to, you can code along as well, but all the materials are already on that website, so we'll sort of take it a little bit easier if we need to. I'll do some coding. Luckily, there's a Slack channel. If anything needs to get copy-pasted, I'll send it over to you through Slack. But I think everything that we need code-wise is like on the site that you can just keep forever. And the main repository has all the code in there as well. All the code references and everything. So if you want to, you can also follow along for each of the slide decks. Like that's also totally available as another option. But yes, if you do plan on following along with each of the components, mostly it's, I added in some of the how to write a dashboard that has an LLM Gen AI component to it. So it's really like those packages that sort of need to get installed. We'll be working with an OpenAI. We'll be able to talk to OpenAI. That just means that you have to have a GitHub token, like a personal access token set up. There's instructions there for that, but that's really why the instructions sort of exploded. It's mostly create a GitHub personal access token and name it into your environment, which is all sorts of more complicated things if that's something really new to you. But if you have any questions, we still have like 5 minutes. So if anyone has any issues with the setup, just let me know and we can just get that squared away. There's a lot of sort of try it on your own and break time. So if something's not working, we can just figure it out during one of the break sessions as well. Yes, I am using positron. For positron, it really is, you'll kind of see it when I go through the very first example. It makes it just a little bit easier to, like when I'm processing data, just to see like my data frame got updated. Personally, on the Python side, it's really nice that there's a drop down for like which Python environment you're currently in, and there's a button you can click that lets you toggle through it. Those are pretty much my favorite features of it. That I pretty much use all the time. I code in R and Python, and it's kind of like, that's also the big thing. Like if R is like one of your other languages, it's like so much easier to set up than VS Code. But yeah, otherwise, a lot of the stuff, like extensions, like everything you do is pretty much with extensions, and most of those extensions work for both, but it's like the variable explorer, the drop down for like switching between environments, like I find that super, super helpful, and that's sort of what I stuck with it. That's like the main reason why I stuck with it. Right now, personally, I end up using positron for all of my like data science work, and then VS Code, it's like, before Obsidian, when Obsidian was like you had to pay for work stuff, like I just had my own like PKM using Foam, and that was like VS Code is for Foam, and then like all my data science work was in positron. So, but yeah, that's how I've like partitioned my work that way. But yeah, at the end of the day, it's I bounce around between R and Python so often that it's just like that was like my main reason why I stuck with it. Or sticking with it. I mean, you'll see it when I introduce myself. Technically, like, I work for the company as well, but that's mostly the drop downs and switching between R and Python are like the reasons why like it even got installed. I'm trying to think. I don't think there's anything super positron specific that you'll see. in this workshop. So like if you're using VS Code, that's totally okay. I think you just have to install the Shiny extension. That's like the only extra component with that. Mm. I think so. There's a couple of things that it comes pre-bundled with, and that pre-bundle of like having the IPython kernel, like there's a bundled version if you don't have it installed and pointed to one already in your environment. That startup cost, like yes, is a lot easier. So if you have R installed and you have Positron, it like finds it, and like there's no more extensions to install. So in that sense, like yeah, that turnkey is a little bit easier in that sense. I haven't tried it with any other language outside of R and Python, but yeah, that's what I've also kind of discovered. I rarely like uninstall it and reinstall it and see what's going on, but it is leveraging like that dropdown. I believe, I don't know for sure, but it does do the same thing as like the Find Python interpreter command palette, but it's just like somewhat nicer where you can click a button and it opens that page up. And I think the engineering team is adding more like wizards to help you create that environment or that Python environment and guiding you towards that way. But yeah, and I also know it's a lot less scarier than using PyCharm. Personally, when I mean, this was also when I was first learning Python, but like that wizard in Python and PyCharm was like, what is happening? Like, so, but yeah, I'm also curious to hear your thoughts about Positron. If you want to like start over from scratch, like I'm also curious what your experience is as well. Okay, so it's 1:30. There is everything that you need is published on this website. It's also in the conference tutorial Slack channel, so you can go there. The slides are also on this website. They're on and I'll show it to you what the website looks like in a little bit. But I believe everything you need is right there. So you can choose to, through osmosis, learn everything that I'm saying. If you're trying to replicate a result and you don't want to actually do all of the hand typing, all of the source code, and everything you need will be either in that repository or in the published website, or there's a link to the source code for the website, and all of the code snippets are in there as well. One of the main things is the setup instructions gotten a little bit more complicated than what is currently listed in the SciPy schedule. Pretty much what I ended up doing is we're not taking out any of the materials that's already planned in there, but given that it's the second day of tutorials and it's after lunch, I've condensed some of the module and testing talk into just slides, and then we'll talk more about, and to make room for getting a chat LLM into a dashboard. So that wasn't something that was originally scheduled, but we sort of found a way to make room for it, just so it's a little bit more relevant to all of the stuff that's going on these days. But this is the website. You can click on setup at the top and you'll end up with the setup page. When we get to the LLM part, there's a lot of time for you to try things on your own. So things around API keys and GitHub tokens, we can work around that as well. If you click on the little title at the left-hand side, you'll get the rough breakdown of everything that we'll be doing. And all of these links are the same links to the left-hand side where you can click on welcome. It's literally my welcome slide that I'm presenting. All right, so today's goal, really to get you building reactive web applications in Shiny. And the first thing is I just have a couple of, let's just raise our hands just so I can get a general sense of where we are in terms of dashboarding and that type of visualization in Python. Um, has everyone used Python? Yes, I'm assuming, but that's good. How many of you have created a dashboard before? So that's like Streamlit or Dash, or maybe you've used Shiny before. Gradio is another tool. Before all of those tools came out, and this is why I never made a dashboard in Python before, it was, I think, like you have to essentially make a Flask or Django app to like just visualize your data, which was very grateful in the last couple of years that all of these dashboarding tools came out on top of all of Python's visualization tools. What about with HTML, CSS, and JavaScript, which is not what we'll show, but there's a couple of concepts depending on which JavaScript framework you've worked with or seen in the past. Shiny might resonate better with you, or not, and I'll try to show you and tease out some of those differences in today's workshop as well. But has anyone had experience with Shiny before? I'm assuming. Oh, that's cool. Yeah, not zero. That's great. So hopefully today, for the vast majority of you, you've never had experience with Shiny for dashboarding before. We'll get you through a really simple basic application. For those of you who've touched it before, maybe some of those fundamental topics will sort of reiterate and get you a little bit more informed about how it works under the hood. And then our goal is really to build 2 applications, one in the first hour, and then we'll slowly build up a more complicated one in the second hour. The third hour, we'll sort of do a pivot on like how we can get an LLM into a dashboard, and there's a couple of cool packages around making LLM usage a lot easier. And then at the very end, I've also found out that the topics that we've set out at the very end, most people, it's one of those topics where unless you're actively needing it right now, which is Shiny modules and like Shiny testing, it's a little too much to go into super in-depth for those topics, but I'm still going to present it to you, but it'll be less like, let's type it along and you'll have all of the code and we'll talk through the code in that sense. And the other nice thing is pretty much the entire Shiny engineering team is here at Posit, and so there's a Slido that I'll show you during breaks, and if you have any questions that I cannot answer, we'll put it all in a Slido, so it's all anonymous. You can thumbs up the questions, and then at the last 30 minutes, I believe they're all going to come in. If not, I'll Slack them or something, and then we can have a conversation just with the engineering team about if you have really specific needs or concerns about dashboarding, like any questions I can't answer, I'm sure one of them will be able to answer as well. So that's one of the cool things that I also try to make room for. It's just this general Q&A about all of our tools, which is also, if you want, you can ask the question about like why Shiny versus blank. They'll be happy to answer that type of question as well. All right, back to, not everything is going to be just me presenting slides, although everything is, it's mostly there for just setting pace. Okay, so we are going to write our first dashboard. In general, give me one second. In general, my suggestion when you're building dashboards is you're probably building a dashboard for like a reason. You don't just randomly like, I'm gonna build a dashboard and have no idea what you're going to put into it. So one of the things when you're building a dashboard is trying to build a dashboard, like try to push that off and punt it off as far as you can. What do I mean by that? I mean, open up your Python script or Jupyter Notebook or whatever and just get all of the code for the data cleaning that you might need, a draft of the figures that you might end up looking for, because the dashboard on its own probably wouldn't be doing a lot of the data processing. You pretty much want to connect your dashboard to a clean data set, and the dashboard's job should be only rendering the figures and tables or maybe text that you really want. Like, you really don't want your dashboard to be like, okay, I'm gonna load up, and then the first thing I'm gonna do is like connect to a database, it's got 1 billion rows, and let me start processing all of that information. You definitely don't want that happening. That'll make your dashboard really slow. People are not gonna use it when it's slow, so get all of your code worked, roughly sketched out, worked out as you can. And then whenever you are able to, put in a placeholder for like, hey, this is a control that I want for my dashboard. And like, something that I do is like, I make those variables in my Jupyter notebook like all caps, just so I can see it. And it's like a placeholder for like, okay, I'm going to replace this with a slider because then I know that that number is going to change and stuff like that. So that's what we're going to do for the first part of today's workshop, which is let's go and write some code so we can get something working. So here is the code that what it's going to do, and I'll type it out so we have people who are following along. You can type it out or pull up the actual slide deck and we will copy paste it from there. But we'll be using the Palmer's Penguins data set. It's a data set about penguins and their various beaks and flipper lengths and weight and species. And what I'm going to do, and this is sort of going through that realm of like making sure you have placeholders for certain things, is I want to, for example, visualize the distribution of the bill length of all of my penguins. But I want to also say that I want to be able to select a certain species and have it overlay or show me where those species are compared to the whole. So I know I'm going to need some type of placeholder that lets me, the user, figure out what species is selected. And then once I select the data set, species, I know it's going to have a filter the data set for that species. And then this is the plot9 code, which if any of you have worked in R and ggplot or heard of ggplot, this is a port of ggplot in Python. And this is the code that will create the histogram for bill length and then overlay the selected species on top of that. And I'll type this up in an actual IDE in a little bit, but what you'll get is something like this. This is not a dashboard. It is a single flat image that has in gray the overall distribution of our bill length, and then in blue is that selected species. This is also sort of like something that I particularly like about grammar graphics or ggplot is being able to create figures like this by layering two data sets on top of one another. That's in some sense how my brain works, because I learned how to do a lot of this data processing stuff from the R side, so a lot of my brain works in the R world, and I'm glad that packages like this exist. And when we talk about the code base, I want to be able to, again, leave a placeholder, which when we're writing Python code, leaving a placeholder means like, make sure you actually have a variable associated with it, right? It'll be really hard to work or try to reason about what is happening if this species was like just built in or hard-coded into the plotting code. And this is, again, my tip to all of you starting to build dashboards is, yes, make your plotting code. If you hard code the species in there, that's totally fine. But slowly, when you rework your code, try to get something such that like you can now change something by tweaking a couple of variables. In this case, one particular variable. And that's your way of like making a really a first pass of a dashboard without adding all of this dashboarding infrastructure to it. Because if your plot doesn't work, it's definitely not going to work in a dashboard. So let's just make sure that something's working now before we start adding all of the shiny components to it. And the nice thing about this is I can change this, and then we get another different type of selection for our dashboard. And so that's sort of the first app that we'll be making in the first hour, or talking you through, is some type of dashboard where maybe you have the option to pick between one of the three species and then this regular static image. This could be in Matplotlib. This could be in Seaborn. If you're using Plotly or Altair, you can use that as well. There's an extra type of thing you have to type just to tell Shiny that you're using Plotly or Altair or any of the SciPy widget plotting libraries. But if you can't get this working in regular code, your dashboard's not going to work. Okay, so I'll give everyone, if you want, about 2 minutes to get this code together, and as you're working on it, I am going to type it out as well. All right, I believe this is... I think it'll be 2 minutes. Now I realize I can't see my timer. Okay. Okay, so I'll talk through each line of code one at a time, and then hopefully it'll be about 2 minutes when we're done with it. So first thing we're going to do is from the Palmer Penguins package, we're going to load up the load penguins function that gives us the penguins data set. There's a couple of functions just for plotting using plot9. If you want, feel free to use matplotlib or Seaborn. This is, in Seaborn, yeah, you can load up SNS, and it is a histogram that we're working with it. I don't know off the top of my head how to do this overlay in Seaborn, but as long as you can get some figure, whether you use this overlay technique or just plot just plot the histogram of what's selected, that's also okay as well. Getting this exact figure isn't really needed for this exercise. And then all we're doing is we're calling load penguins to get us a data frame called DAT. And so I can run this, and I believe we can see our little data frame here. If you're using VS Code, or not using VS Code, if you're using positron, this is one of the things that's really nice when you're exploring on top of pure plain VS Code is your variables, you'll get some type of really quick summary right away. So if you're doing table joins or doing filters, that's really useful. You'll notice that if I select my species and then create a subset of the data set, we'll get a little bit more information that we can visually confirm that, yes, if we select based off of a species, it is going to be fewer rows. And then one of the other nice things is you can click on the data button, the data viewer, and you'll get a couple of quick summary statistics on the left-hand side and just literally be able to explore your data set right within the IDE, which is really useful to look at missing and general shapes of your variables. So we are going to provide a variable or a placeholder that gives us our species. So we're going to say, like, let's just look at the Gentoo species for now. Because of how the layering system works in our plotting library, we do need a subset of our data frame that just contains the species that we're interested in. So this data frame, SEL for selected, is just looking at the Gentoo species. And then a little bit of a really quick intro about plot9, the plotting library. It works on a layering system. So the first layer is going to be ggplot, our base blank canvas. And then we're going to say in AES, which stands for aesthetic, in GG or grammar of graphics language, the aesthetic is some variable that you're using that will tie to a column in your data set. So I'm going to say AES x equals bill length mm. Bill length nm is one of the columns in our data frame. And I'm going to say whatever you do late on the next layer, the x-axis is going to be tied to the information in this particular column. So we're not really in a visual plotting workshop, but this is how plot9 works, and we'll be seeing plot9 and other sorts of plotting libraries as we go. And then the first layer I'm going to say is I'm going to have a histogram. That histogram is going to have a data set called DAT. DAT with the x-axis bill length mm is all of our data, and I'm going to say make it grayish. And then the second layer on top is like on top of that layer, do the same plot, but on our selected data frame and make it bluish. And then making sure that the two bin widths are on a comparable scale. And then I'm adding a nice little theme here, theme minimal. One of the fun things is there is a theme XKCD that you can do as well. And I believe, nope, that's because I didn't import it. XKCD, all right. Yay, live coding. Let's see if this works. Nope, that's the wrong. There we go. That looks XKCDE. It's got the little squiggly line. But yeah, so that's in general how it works. Things that are optional, you don't really need the theme component in here. If you run it without the theme component, you get this very classic gray background. If any of you have coded in ggplot R before, this is the same type of default. The reason why it's gray is it helps some colors sort of just pop up a little bit more instead of yellow on a white background sort of doesn't show up very well. Okay, so now that we have that particular code, we can now go and start adding different parts of a dashboard to it, right? Once you have code that kind of like, yeah, this is a pretty good placeholder, and we have our little actual placeholder for a component, now we can start thinking about how do we make this into a dashboard. And again, make sure that you have the raw components of everything that you want. Like sometimes I'll spend even more time in this phase just to make sure maybe I have my proper titles, maybe you have decimals that you want to make sure that they're rounded to 2, maybe you're using some type of Python formatter to make sure you have a % sign. Sometimes I'll spend a lot more time making the figure here prettier just so I don't have to deal with it on the dashboard and like wait for dashboards to load and stuff like that. One of the things that I also realized I never introduced myself. So one of the things that I do is I teach at the University of British Columbia. I teach a few courses in their data science courses, and I also teach the Masters of Data Science program. The other thing that I do part-time is I work in developer relations for Posit, which is a lot of the tooling that we'll be seeing today. The Shiny team is part of Posit, and I work with them and try to help convey and show how to use their tools. What was I saying? One of the things that I worked out when I was teaching and working with my master's students was when you create a dashboard, sometimes it's also really useful to have another script or another notebook that is almost a one-to-one, like, this is the figure, this is the code I'm going to copy and paste into the dashboard. You can even go as far as turn all of your figures into a function, and then both your dashboard and your notebook load in the function. So if you change one, it'll update on both. And again, that's really just to give you another entry point where if you need to quickly make a modification to a figure, you don't have to do it by like editing the dashboard code. It's so much easier to do that iteration process when you have a little notebook file and you're just like, okay, how does the colors look? Okay, this looks terrible. You don't need to wait for the dashboard to refresh. It's so much easier to work with a notebook or a script file like that. So this is something that I do pretty often, and I've also told my students is, yes, create another Python file that just has all of your prototype work, and then because you have a figure, it's literally cut and paste or copy and paste with some other dashboarding components to it. And that's sort of the first example that we're going to be working on today is now that we have our figure, how do we go and add our dashboarding components to it? So the first thing that we're going to do is think about the user interface, right? And another thing that I tell my students as well is when you're coming up with a dashboard, don't just start trying to code up a dashboard. Like what I actually do is I get a piece of paper and I draw out, and this piece of paper is about the size of a laptop screen. So if you're thinking, I want this dashboard to be in full screen, a sheet of paper is a pretty good proxy for that. And then you literally box out what you expect your dashboard to be. It'll help you with sometimes some dashboards, your goal is nothing scrolls on the page. Then you're gonna have to make some decisions about what that means. Other times you might be okay with a dashboard that has scrolls because you're trying to convey a lot of information. That's also okay. But I like to have it and drawn out on a piece of paper just so I know I have space for everything I want to show and it's not going to be too cluttered. It also is a really good way to prototype like a user experience of, we'll see when we pick our first component is this, do we use a drop down? Do we use a radio button? How do we want to interact with this? So much easier to just like draw it on a piece of paper than like especially if you're very new, to like go into documentation and like figure out like what is the actual thing I'm looking for. So one of the things is, I have to remember to close this tab, is in Shiny, there is a really nice page on the Shiny for Python documentation. If you go to the top for components, we actually tried to make selecting all of your components a little bit easier. And so here are all of the different input components that you might want to work with. So we are going to take, I think I just gave it away, but even here, what might be a component that you want to use for picking and selecting that penguin species? If you kind of looked at the slide, I picked radio buttons, but there's also nothing wrong with having a single select button as well, right? So that's going to be a decision that you as your dashboarding author are going to use. In this particular case, why I went with radio buttons is because as a dashboard, this is a one plot, 3 penguins to select from. Why not just show everything on the screen? Because we have the screen real estate for it. If you're trying to do a whole dashboard around all of these penguins, yeah, maybe depending on the number of filters I have, I might need something like a single select, just so I'm taking up less space. Maybe your dashboard actually allows you to work with multiple selects. And so these are considerations that you might want to have. Selectize is really nice if you have a big long list, and it also gives you the ability to search for items in that list, right? So, if we're thinking, I just moved to Canada, but if we're thinking about in the States, yes, if you're trying to pick between all 50 states plus provinces and plus Washington, D.C., this is a really good option to give the user to filter with. Another thing I kind of wish a lot more websites did was when they give you the option to pick the country, like sometimes I rather just, they don't always put the United States under U, and sometimes I end up scrolling and then it's just like, no, it's really the first one, like why did I scroll all the way down here, right? So sometimes there are decisions like that. I kind of wish Selectize was used a little bit more often. There's single and double versions of these. Just since we're looking here, we have slider inputs, so if you need someone to pick a integer or any continuous number, those are available. You have ranges. Ranges also work with dates, so if you need interface for that. Switches are like Boolean yes or no. Text boxes or text areas, any type of arbitrary user input, and I think they do the escaping for you. You have date selectors. If you need like a prettier date selector, you can do that as well. One of the other things that's really cool about Shiny is there's an input for you to have the user upload like an arbitrary thing. And you can go and check, like, is this a CSV? Is this a Excel file? You use your current Python skills to import that data set, do the error handling, but at least you have a way to get a file from the user. And all sorts of other options as well. So let's think about our very first application. I'll talk through the code, and then I'll show everyone how you can get this code actually running as a dashboard. So we'll be using Shiny Express, and we say from shiny.express import UI, because we're now working with some type of UI element. I picked radio buttons, so literally, even though I work for the company and I talk to the engineering team a lot, I have this page open every single time I'm working with the dashboard, and I say, I want a radio button, and I click on Wi-Fi. Please work. Uh-oh. I click on the radio button option. Okay, is it? Oh, this is an internet thing. This is because the workshop's just started, and I bet everyone's all downloading something at the moment. Yep. Hopefully this didn't happen in your other courses. No internet. Okay, it's pretty bad. All right, that's why I have slides. Okay, so what I actually end up doing is I very much go to that documentation site. I scroll, that looks about like a nice thing. Maybe I'll draw it out on my dashboard because I'm like, oh, I didn't know that component existed. But now we have radio buttons. We say UI.input _ radio buttons. What's also really nice is all of those things that are considered input components all begin with input _. So it helps you a lot with tab completing if you're in the IDE. And then we have radio buttons. The way Shiny works is everything needs to have a unique ID. And you'll see that being used when we start to connect all of the parts together. But every single input component, its first parameter is going to be ID. And this is how we can find the information that input component has later on by this ID. We're not using it yet, but if I need to find what the user selected, I will find it by the species ID. You have an optional parameter to set the label. So this is like when you have the input, like what title gets shown up here. And then regular Python list, what are the actual options? And you have this nice little input component right here. It doesn't do anything other than change the input components, but you can slowly start to see this is now going to be a way where we can modify that variable that we used as a placeholder, and that's how we're going to connect those two things together. So how do we get this code working like actually for real? I'm going to copy this code, and I am going to open up my IDE. And so step number one, and I'll push up all of the code that I'm typing in between breaks. The first thing that we're going to do is when we're working with, if you've ever worked with any dashboarding application before, you'll see pretty much every time you're working with an application, it's either app.py. Same thing holds true for Shiny, except in Shiny, and I don't know about like if the same exact cases for Streamlit and all of that, is as long as the file begins with app, you're okay. There's like buttons and things that you can click to sort of load the application. If it doesn't begin with app, you can always type the command in the terminal to run it. But with the Shiny extension in VS Code or in Positron, when your application begins with app and you click the little play button, it will go and actually run the app as a Shiny app. So we'll call this app penguin.py. I'll paste this code in here. And then if you're in VS Code, you can click on the little play button, and it will essentially put into the terminal this Shiny run command, which just, this Shiny run command. And eventually, I believe, D is not found because and it will go and give us our application. So this is our little Shiny app running from this particular file. I'll do that again, just so we're all roughly clear on how this works. If you have the Shiny app in Positron or VS Code, you can click this button. If you don't, and you have Shiny, the Python package installed, which you probably do if you're trying to create a Shiny app, in the terminal, you can also run Shiny run. And then, where am I? I am in the root of the repository. So I'm in workshop/app penguin.py. And what I also suggest, if you're working with an app that you're, a smaller-ish app that you're prototyping, I also put in this -- reload flag, and what this means is anytime you save this file, the app will reload automatically for you. So you get somewhat of a faster feedback. Otherwise, you have to Control-C, shut the app off, hit the up button, hit enter, and then let the app reload that way. So the reload flag allows you that anytime you make a change to the application, it will go and reload. One of the other things that might be useful is sometimes you might want to manually select a port, just so it's running on the same port. Otherwise, it ends up picking like a somewhat random one. So this is saying it's running on 8,000, I think. Yeah. And now if I do something like print hello and I save it, I believe the app is going to maybe reload itself if I'm looking at the right one. Yep. And that reloading is because I passed in that -- reload flag. One of the things that I also learned is when we get to the LLM part, like turn reload off, because you're going to be saving your file a lot and you're just using up tokens. We're going to be working with the GitHub models, so you can actually get access to all of the latest LLM models, but then there's limits to them, and I've definitely hit limits by just hitting save way too many times, and then just my app won't reload properly for like the next hour. But that is a really nice quality of life improvement that we can use. Okay, the next step. Yep, so in positron, click the little button, or in the command line, run the reload app. One of the other things that we can do is, you'll notice that by default, the radio buttons were put in vertically. And again, when you're drawing the app out, or when you look at the documentation and you look at all the other parameters, you might find a parameter called inline, and it'll tell you, hey, like this means that we'll just shift the way that the radio buttons are presented. And again, if we're thinking about what we want our app to look like, do we want something taking up more vertical space, or if it's a screen, let's just use up the horizontal space and put the big app below. Again, you don't have to have those decisions worked out always from the beginning, but just know that there's a lot of these things are probably available to you. So if something looks like, why is this taking up a little bit more space? The documentation, again, look for all the little parameters. I'm always surprised, even though I work with the engineering team, I sometimes even write the docs. I'm still surprised of what's in here as like parameters. And so if you learn anything from today, it really does become, I'm showing you where in the documentation page to look, and just have it open on like in the command tab, alt tab, like really readily available. If you have another monitor, just put it on another monitor. That's my main suggestion to you. And so what we can do is run inline equals true, and it'll just shift the order of that, shift the direction of that, of those choices. So if we go and do that and hit save, and again it'll auto reload, you'll see that like now our radio buttons are now in there. And that's cool. You can now imagine, let's just take that plot that we just made and shove it down here and connect the two things, and we have our first app. So that's essentially the steps that we're going to be doing. Okay, so we want to go and add in the figure. I just showed you all of the code that we need to add in that figure. But the thing is, all of that code that we just had from that first example, if I just copy and paste it in there, it won't work. Why is it not going to work? Part of it is it's a dashboard. A dashboard is like a website. If we just say like, hey, here's a whole bunch of Python code, like website, go make this, it's not really going to be able to do that. So we have the code, which is good. We just now need to modify this little code just so we put in the little dashboarding components so it knows how to go and render the actual figure in our dashboard. And so you'll see here, if you try to do this, you'll get a little type error. I try to like make sure that the error message is really clear. At the end of the day, what's happening is all of these UI components, you're writing Python under the hood. It's literally like, here's the text for the HTML. It creates an HTML file and shoves in that text in there. The short answer is like, this doesn't make sense in HTML. And so that's why it's erroring. Okay, so how do we go and fix this problem? We now need to talk about output components. So we had input components, we're going to talk about output components. And I actually think I skipped a slide deck. I did. I think I skipped the slide deck, but it's okay. We're going to talk about output components. And now let me see if the internet is working. No, it is not. Okay. We can imagine the page of the input components that I just showed you. If you scroll a little bit further down, it is the same type of formatting, but now it says if you're working with matplotlib or iplyleaflet or Plotly or Altair. What other things? Like a data frame. What other outputs are there? Tables, figures, any arbitrary text. All of those components have an output version to it. So Plot9, if you've never worked with Plot9 before, I'm just going to tell you, Plot9 is built on top of Matplotlib. So we're going to use the same type of output format that Matplotlib uses to insert our Plot9 figure. Seaborn also is built on top of Matplotlib, so you'll use the same type of output component for that as well. For many of you, I know in SciPy, there's always a workshop around like IPy widgets and having all of those components because to have those interactive visualizations in your notebook, there is ways to input your IPy widgets as well. It is a separate component. So what we really do is we go on that page, the components gallery, we scroll down to the output section, and then we just find like, my paper that I drew has this thing. This thing is a plot. Let me go find the component that renders a plot and click on it, and then you'll notice that what we have is a render plot decorator. So what this looks like is in Shiny, any piece of input or output that sort of reacts to one another in the application, you wrap it around a function. So we create a normal Python function. So a lot of Shiny apps really does look like a file with a bunch of Python functions. It's different from a module. If you've worked with Python and imported other stuff before, you don't really import it's not like you're saving all of these functions into a file and you're importing them. It is Shiny's way of encapsulating, like, here's the code I need to run to render this plot. And that's why it's important to have everything as a function. So at the end of the day, all your output types will be wrapped around a function. Typically, it will match the ID of the input that you're trying to work with. So I'm writing like a species plot. I might just call this species. You can also name it as like plot underscore species. So in your code, what the inputs are in this plot are all together. The other thing that is important is make sure you return your plot. So a lot of times, especially if you're working with Matplotlib or in Seaborn, you'll create an axes figure, like the AX figure. And sometimes if you're used to notebooks, it's like once the AX figure is the last thing in the notebook, it just renders on its own, and you never really have to work with the axes object. But do make sure that if you create an axes or a figure object, return the actual object. That's really important. Otherwise, Shiny has no idea like what you're doing. Like you created a thing, you just never gave it to me. So another important thing, make sure you return your output. The other component, and this is the thing that's going to be very weird, new to people who, especially for me who solely works in data science, I don't really use decorator functions a lot, but they're used all over the place in Shiny. You don't have to know too much about what decorators are, other than it's the @ symbol before a function. And the short answer between what a decorator is there's a special function called render.plot. It takes in a function that generates the plot, and then returns another thing that can run that Shiny understands, like, okay, I'm gonna render this plot, I need to create the HTML for this plot and shove it into the website. You'll notice that you don't have to write any HTML or CSS or JavaScript to make that happen. That's all handled by this little magical decorator at the top. You also don't really need to write your own custom decorators as far as if you're taking this workshop. You don't need to worry about that either. Just know that in order for you to place a figure somewhere, you need to find the correct rendering output object. In our case, it's render.plot, and then here's the code that renders that plot. So if we go and do that, you'll note I put in the little hashes for the things to pay attention to. This code right here, exactly the same code that we just talked about. I literally cut and pasted that code. We have some setup code in here that we'll talk about and work with a little bit more, but all this is doing is loading up our data set, and then this is rendering our actual figure. And then this portion right here, defining the function, decorating the function, that's what gets us that figure right here. And so we have this radio button, which is up here. We have our figure, which is down here. Nothing's really connected yet. So let's build on our application. So all of this part, exactly the same as before. I haven't really changed it. What I ended up doing is our previous code that we just did to mock up our example, we still need to load up our data set the species, set the subset. That's all right there. That's totally fine. This is something that just, your script needs to load some data, so you don't really need it really in this particular plotting function. In theory, does it really hurt for you to put this in here right now? Your app will run. It just means that any time that it needs to regenerate the figure, it's going to reload the application. So there's performance things you might need to worry about or keep track of, but that doesn't mean the app's going to break. So right now, once the app is loaded, it's as far as you understand it right now, it only loads it once, and then whatever happens later on, it's using that loaded data set. And then down here, again, we're returning a figure. We are defining, we're saying like anytime you want to update this figure, call this function, and then we say in the dashboard, put it right here in this location, and we say, hey, you're going to go and generate a figure or a plot. One of the other things that you've noticed, if any of you have coded in Dash before, you'll notice in Dash you have to have a whole separate section for your UI, and you have to say this comes first, this comes second, this comes third, and then a whole other section that is like this that defines where things are. In Shiny Express, our UI came first, so we rendered it first. There's some code in here, sure, but it didn't produce any input or output, so kind of nothing happens on the page. And the next thing is, oh, you have a figure. So then we have our radio buttons on the top, we have our figures on the bottom. So think of it as where your component is sort of where it gets rendered on the page. In the second hour in a little bit, we'll see a more complicated example, like what happens if you actually need things to be next to each other. We'll talk about that. But essentially, it is where your code from top to bottom, that's sort of where things are going to show up. You don't have to keep track of a separate UI file and a separate code compute file and things like that. Cool. So that's our first app. Now, here's the magical part of what really makes Shiny different from all the other plotting libraries. Right now, this kind of, I would say it looks very Streamlit-like if you've used Streamlit before. It's kind of like Dash, but without the two components to it that you have to keep track of. But each one of those other tools do execute their code slightly differently. Shiny uses this idea of reactivity, and we'll talk more about reactivity in the second hour. But reactivity is, again, the secret sauce of Shiny. It's what makes it unique. It's how my brain works now when I'm thinking about dashboarding. And the way this works is we need the ability to say you have all of these input components. It has an ID called species, and I want to capture whatever that input component returns, right? So if it's a radio button, it would make sense that the radio button returns you a string, and that's actually what happens. If it's a slider, you would hope that it returns you a integer, and that's what happens. So there's some logical sense to this thing. But what we want to do is, hey, we have all of these inputs. I want to get that information out of a particular input. How do we do that? In Shiny, you have the input parameter available to you. So in Shiny Express, you'll import the input object. And this input object actually keeps track of all the inputs you have on your application. That's why that ID is so important. And the way you say, hey, I have this radio button, its ID is species, and I want to get the value of what's selected, is you say input.species. This species is literally the same text from the ID. And then you wrap it in, you pass in, you call it like a function. And what that's doing is it's finding the input and calling it, and then getting the value out. So when the user makes changes, it's going to rerun this particular function and then get that new updated value. And that new updated value plays a key part in how our figure gets rendered. Specifically, we are using that input to change the subset of our data set. So what I like to do, especially when you're starting out, is yes, save the variable of the input that you're using, called species, and then passing it back in right here. Right? So before, species was equal to Gintu or Attadale, like the hard-coded string. Now that we created those radio buttons, I just need to say, hey, just replace that with input dot whatever the ID is. Don't forget the round parentheses, so it knows to like get the actual value. And then the rest of your code doesn't change. Right? So that's why it's really important to get that first step right. Like get your code working, refactor it a little bit so all of your inputs become separate variables, and then when you get to this point, it's input.species, and then now you have everything you need to connect those two parts together. This is my favorite part of working with Shiny. If you've worked with any other dashboarding library before, this mechanic that I just showed you is handled differently depending on what framework that you're using. But this is how Shiny does it. There's an input object, and it keeps track of all your inputs. So let's go and run that code in our little dashboard. So we still have the DAT. And again, all I'm doing is essentially, I'm pretty sure I can live code this just to prove it to you. I'm putting my code in here. Why am I putting this code in here? Is because I know that the subset's going to change when the input changes. So it makes sense to call this code, this plotting code, that subsetting code every time the plot regenerates. So I'm moving that subsetting code into the plotting function. And then up here, we now need to say input. I think that's all you need. And then over here, all I need to say is input dot species. Why is it species? It's because this radio button and this ID is called species, and that's how it ties those two bits together. My app still hasn't crashed, and now I get a little reactive application. You can kind of see like the blue kind of changing as I'm moving. And that, again, when I make a change to this radio button, and this is the reactivity part, it knows that it needs to rerun this plotting function because I've tied the input to this function. Like we'll talk more about how reactivity works, but it kind of just figures that out for you. So if you've worked with JavaScript before, there is no concept of a callback here. You don't have to manually keep track of all the inputs to generate this function. You just go and use the thing. And Shiny is really good at just figuring out what information it needs to get for that interactivity. And so this line right here, as magical, I find it magical as it is, like that is the core component of Shiny and reactivity and what makes it really nice. So we get that string from the input, we use that same species, the rest of the code doesn't really change, and now we have our first little application. And I believe that is my slide deck. All right, so I believe that is our first break time. If you haven't and you want to follow along, this is the actual application that we just created. And so if you want, stand up, walk around, stretch out your legs, or you can go and get this application working. At the very least, get the code on your computer and try to actually run it on your computer. And We have a break until 2:30, but take about 5 minutes to see if that works, and that way everyone at least is able to stand up and give this a try. And I will also leave this up here. Oh no, it doesn't fit. Hold on. There we go. We'll move it. Ow. I am making it worse. Okay, hold on. There we go. All right, so like I said, if you have any questions about anything that I'm talking about, you can raise your hand. If you have a really specific question about internal implementation or a question you want us to address at the last 30 minutes of today's workshop, there's a Slido, type in your question, and then we'll try to answer them all at the end. And I'll also try to take notes during the Q&A section, and then I'll upload all of those questions and answers to that website. So we're all keeping track of links and answers to all of that as well. But yes, give this a try, or come back at 2:30, and then we'll go over the solution. I'll show you running this again, and then we'll go over to the next section. All right, because one of the questions is actually relevant to like getting stuff running. If you're using VS Code or Positron, you can have installed the Shiny extension, and you'll get a little play button. Otherwise, Shiny run -- reload, and then point it to the application file. That will go and run your application. When you run things this way, it really doesn't matter what your app, like what the naming of that application is. You can call it penguins.py, and it will know to run it like a Shiny app. The app prefix is really just making this button work. So there's like quality of life things that you get as long as you follow the rules. Otherwise, if you can type the command, as long as you know what you're typing, you can totally do that. But yes, the reload is what is giving me the ability of every time I save the file, the app kind of reloads as I go. there's actually some questions I know how to answer, so we'll talk about some of them. This is recorded, right? So we have proof that I can not everything needs to be punted to the Shiny team. I'll give everyone the actual time that we promised, so you can kind of see some of the questions that are coming up, and I'll sort of check them off right away. The short answer to this last one is my computer doesn't have internet right now, so I think that's proof that you don't need internet to run this stuff. Okay, so it is bottom of the hour, and yes, the short answer is if you're trying to work in an environment that's actually air-gapped, you still need internet to install Shiny. That's something you still need the internet for, but no, having a app file and using Shiny run to run that app file, you do not need the internet for that to work. There are certain things that might need the internet. A common thing that I run into all the time is math jacks for LaTeX and formula rendering. That just needs the internet to run for some reason or the other. But at the end of the day, you don't really need a live internet connection to click the play button or run Shiny live. Shiny run. Yep. Yeah, I don't. Yes. So the question is for certain CDN things, can you download the actual JavaScript bundle and then just point it and just include it in the HTML? The answer is yes, you can do that. That's going to be a Shiny team for show you the code to do that. But at the end of the day, the all Shiny and all of these tools are doing is letting you write Python and it writes the HTML for you. So essentially there's always a mechanism that says, what is it, in the header you can have an include or a link tag. You put that in there with that link, and it's just a link to the actual file you just downloaded. So you can totally do that. Yes, things that might download on the fly, you can totally just hard download that. In Shiny UI, it's shiny.ui.tags, and then you have access to the Python function version of all your HTML tags. So if you know how to write raw HTML, you call that particular function and just write your thing. And then when it creates the HTML for the actual application, it's essentially copy and pasting. It's just, I wouldn't be surprised if it's an F string that just dumps whatever you put in there, right? So totally can do that. So I think that's answered. One question is Shiny Live. Shiny Live is a really cool service. It is not like a gist. So Shiny Live is really built on top of the last few years, but the last couple of years around just WebAssembly, which is run Python in the browser without having someone install the thing. So Shiny Live is a tool, or it's a website that allows you to, here's a Shiny app. It's clearly running Python, but it's in the browser. I didn't need to install anything. So Shiny Live is this service that allows you to put in a Shiny app here, and then give you Shiny app on the right-hand side without having anything installed. There are a few limitations. The syntax is a little bit weird, but yes, you can have a requirements.txt file, so certain things can be installed. It's all built on top of PyIodide, so if it's installable by MicroPython, I believe, then you can install it in here. But not everything is pip installable in Shiny Live, which is really on top of PyIodide, which is part of WebAssembly. But a lot of the PyData stack is already available to you. So Pandas, Seaborn, Matplotlib, scikit-learn, I think, is all part of just PyIodide. It's separate. It's not even Shiny Live specific. It is just what you get as being able to use Python in the WebAssembly ecosystem. That is just available to you. What's really useful about Shiny Live is like sometimes I'm actually debugging apps in here. You can do that. What's also really nice is you can click on the little share button and I can give you this URL and you will have the code and the application. It's really really nice if you're trying to prototype something and you don't want the other end user to install all of this Python stuff. You can do that. The short answer is all the code is in the URL, so like the Shiny Live code ends up being like super, super long. I don't know how it's encoded, but it's not the actual raw string of your code. So it's saved with a little bit of space, but you can totally, I can copy this URL, open a private browser, paste it, and it will give me this application, right? So the question was, is it like a gist? It kind of is like a gist, except you don't see the code until you run the actual link. But this is another tool that's available to you in debugging or sharing Shiny applications. This is really cool for prototyping certain things where you're like, I want to prototype this and I want to show off a prototype without having the end user install anything. This is totally free to use and you have the code kind of bundled with it as well. Yeah. It's running on your, this is running on my laptop. Clearly the internet connection's working. But yes, that's also, but it's not, the code running on my laptop is not a feature of Shiny Live. It is a feature of WebAssembly itself. It is, that's why you don't have to install anything. The whole Python bundle and all of that is in your browser right now. So I am pretty sure if I look at the network tab, there's like a pretty big bundle that sort of just got loaded on my computer. But yes, it's on my computer. There's the website, yes, is hosted somewhere, but nothing you type in here is like what we see on the other side. Unless the site itself has logging enabled, but if you put in a data set in here and not supposed to, yeah, technically it's on your local laptop, but probably wouldn't want to do that to begin with. But yes, you can sort of upload stuff in here. It uploads onto your side of the browser. That's all, that's what's happening. But yes, it's a really cool tool. There aren't as many examples on Shiny Live, like that initial page, but nothing stops you from copying and pasting this code and pasting it here, and I believe this works. I might have to set up a requirements.txt because of Palmer penguins, but I think it's working. Maybe we have to go back to it. Oh, no, there it is. Yep, so this is on the web browser. It's not really running on, it's running on my computer in the web browser, but it doesn't require me to have Python and Shiny and all of that installed. So this is, again, really cool way of prototyping things or showing off other features of things in Shiny. And again, this is all built on top of the last couple of years, the whole WebAssembly toolkit. And the Shiny team sort of just leveraged that to make sharing Shiny apps a lot easier. And again, I can click on share, and I can pick one of these links and give you the link, and then you'll have this version of this application you can embed in a slide deck or just show or send it off to Slack. You can totally do that. We actually do that very often when we're trying to debug stuff. But yeah, that's Shiny Live, and it's a really cool service. And one of the other questions is, this is the one that I wanted to talk about before we go into the next session, is yes, there is two different ways you can write Shiny code. One is called core and the other is called express. I am today showing you express mode, which is a lot less code. It looks a little bit more like Streamlit, less like Dash. The core mode is the more traditional route where you have a variable that defines all of the inputs and a separate section that defines all of the reactive calculations, and they're two separate things. In general, in my day-to-day, I haven't really found the big limit of express yet. With Shiny core, you do have potentially more flexibility to refactor things, but I haven't really, again, personally, I haven't really hit limitations with Express building single page dashboards. yet. I haven't hit it yet. Even in scenarios where like I'm going to go through this exercise, doing something in Express, and then like it's like, oh, it works with all of this LLM stuff with like multi-pages, and it's like, okay. So it does get you really far. The other part of this question is, can you mix the two together? The answer to that is no. So you do have to make like an initial decision of like Express mode or core mode. It's in some sense also similar, I would say, like to Plotly, where like I believe 90% of you, when you use Plotly, you're using plotly.express as PX, and you're just plotting Plotly code that way. And very rarely are you using like Plotly, like the core version. Like even I rarely use the Plotly core version for certain things. So yes, there are two modes available. Part of it is also historic. Shiny was available as a dashboarding framework in the R community, and they just ported it all to Python 1-to-1. So that's why something like core mode exists. And then to reduce the boilerplate and code you have to type in Shiny, they created Express mode. I'll leave that question up so like the engineering team can also get a crack on it. And yes, it does support ggplot, matplotlib, and Seaborn, and Plotly, and Altair, not just plot9 and ggplot. So the answer to that is yes. I'm just showing it because that's how my brain works. My brain does not work in matplotlib plotting. All right. Okay. Next slide deck. This one is just me talking at you for a little bit. And I wanted to talk about the core thing that makes Shiny special, which is reactivity. There's a couple of links to other presentations that have also talked about reactivity. Shiny for Python has been around for a while, so yes, all of those talks are in 2023. They're all still very, very relevant to this particular topic on reactivity. I literally actually just took the diagrams you're about to see from Gordon Shotwell's talk. But we'll talk about how reactivity works. And for any of you who have worked with any other plotting framework before, this is the part that will be very different with how Shiny goes and figures out how things are connected to one another and how things need to be executed or re-executed. So again, reactivity is the key word when you're talking about Shiny. It is essentially how it all works. And essentially it is a mechanism that allows you to connect the output to an input, and Shiny goes and figures out how those things are linked to one another. The benefit of reactivity is you don't have to write a callback. So in Dash, all of your output components, you have to like say like, I need to track what the input is so that anytime the input changes, it knows that that's what the output is. Writing callbacks, if you've written JavaScript apps before, one of the pitfalls is like it's a lot of manual accounting, which means that you could put an input somewhere and if you never explicitly write the callback, those changes you're making aren't updating the application. Again, it's sort of, if you're keeping track of your callbacks, maybe you'll notice that like, hey, when I click on this, the app isn't loading or changing, and that's how you catch that you didn't write a callback. But at the end of the day, Shiny is, one of the things that makes Shiny different is you don't have to write a callback. The way it handles that process is through reactivity. And I think it's pretty intuitive. You say input, the name of the ID, parentheses. Maybe the parentheses part's a little bit weird, but that's how you link the reactive parts together. So how does this work? Let's say we have a fairly complicated application. All of these rectangles are inputs. We haven't talked about reactive calculations yet, but you'll see it in the next app example that we're building. And then we have two outputs. One is a model score, and the other is like some API response. So this is the application. When you run Shiny, it finds and realizes, hey, you have a whole bunch of stuff in here, and it just knows about them. When the application loads up, it's going to be, hey, what needs to be displayed on the page? Okay, I need to show you whatever this model score is. Well, maybe it's a piece of text that gives you like the R² number. Let's just use that as the example here. It's a piece of text on the screen, and it's like, okay, you told me to show you this piece of text. That's one of those output components that I talked about. In our previous example, it was a plot. It could be a data frame table. Pretend that this is a piece of a render text element. So the way this works is it goes and runs that output function, and in the output function, you saw that it's like input dot something parenthesis. When it runs that, it goes, oh, you told me to look up something called filtered. Filtered is the name of that ID. Filtered is something that is, in this case, also a function. When it goes and calculates, it's going to be like, oh, you told me to go look up this input called account. And now it knows to look at the account input to see what gets filtered. But filtered also depends on a larger data set. So it's like, okay, I need the sample and the account. But sample, well, when it runs its code, it's going to see another input call in some sense. And then it's going to look up and it's like, okay, in order to get sample, I need dates and sample size. And so the arrows are drawing in a downward fashion, but it's really looking in reverse in how things are calculated. So that's how it goes and generates the model score. Now it knows how everything's connected. It's now going to run everything, and then you get your R-squared number on your website. And then it goes and says, oh, wait, you need this other thing displayed on this page, this API response. What does it need? Okay, it runs that function, finds that it needs filtered. Filter's already been calculated. It's already there. Essentially, it's already been cached. So giving you the API response is really fast. It doesn't need to go and like work its way all the way back and recalculate everything. It's already there, so let me just feed it to you. So reactivity, one of the other things you get from it is it tries to do the most efficient computes, like what needs to get computed or recomputed. It tries to figure that out in the most efficient way. So that's how reactivity works. So if we go through another example of, let's say the user changes the account. Maybe it's a radio button, a drop-down piece of text. When you go and change one of the inputs, because this diagram, like what you see visually, has already been created and being tracked of in Shiny, it's going to say, okay, everything downstream of this change is now invalidated. So it will go and invalidate everything downstream. And then you go back to the same process as before. You asked me to show you a piece of text. I'm going to run that function. It depends on filtered. Filtered needs to get recalculated. Okay, the account number changed, so that's how you get a new filtered data set. But the sample didn't change because those inputs didn't change. So we can still use the old cached value of sample. So we don't have to recompute that, right? You can take this idea to extreme of like if each one of these steps took 10 seconds, changing account only caused a 10-second change instead of a 30-second change. And then because filter changed, it invalidated the API response. You also told me to show you the API response on the site. It's going to go and be like, okay, filter's already been calculated. Let me just give you that cached result again. So now if we go through the example, like what happens if sample size change? So it goes through the same process. Everything downstream now gets invalidated. So now everything is blank, and then you're back to your initial state, and it says, what needs to be drawn on the screen? And you go back through that very first example again, right? So just by saying input.id parenthesis, that's all it takes from you as the end user to keep track of this graph. You don't need to, again, write a callback because all of these arrows essentially is what you have to do depending on the framework you're working with. Like when you hear callback, you have to keep track of all of this. You have to write it in your actual code. In Shiny, I have this thing, I need it right now, and you just let the graph figure itself out. Right? So that's the really cool thing about it. You never really have to worry about, oh, I never connected dates properly. Like, as long as you're using the date input, like, it's up to you if you mess that up, like you never used it and you're still using the hard-coded date, which I've done in the past. Yes, like that is a mistake. But you don't have to keep track of, like, let's say you're thinking dates, this input was being used in like 5 other places. You don't have to keep track of that anywhere. You just go and use the thing, and the reactive framework will go and calculate that for you. And it will go and figure out what is the minimum amount of extra computations or executions it needs. So that's how Shiny works. Like by magic of like input dot paren, that's kind of what you need, which is kind of cool. All right, so let's go and for the next, might be over time now that I'm looking at like my own schedule. Let's work on a more complicated application. Let's build an actual dashboard, and we'll use some of the techniques that I just talked about in the first example to go and build this dashboard. So we will go and build something that looks like this. Anybody have any ideas of what do they see? I'll take any volunteer. What do you see? You can call out an input, you can call out an output, you can call out a visual component if you want. Slider, yes, yes. I'm also a university teacher. I'm okay with just standing here until someone says something. So, but yes, you have a slider that is on the left-hand side. One of the other things that's really hard to tell, also the fact that this is a static image, is like there's a little arrow here. And so these inputs are actually on a collapsible sidebar as well. Since the internet for that site isn't working, and I'm not gonna wanna wait for the site, there's another part in that drop-down on the site that said components. There's another page that says layouts and layouts. A sidebar is a particular type of layout. So you can get the boilerplate code on how to make this little sidebar thing go away. Each one of these things are cards or value boxes, so we can have really important metrics sort of take up a little bit more space, have a nice little bounding box around it to give it a little bit more visual distinction. And we can put information in here or like actual icons. So these are really good for like those big top level metrics that you're interested in. In this particular example, all of these are going to be different types of output. This is going to be dependent on a render text output because when the sliders change, I expect the numbers to change. So it's going to be render text compared to before, which is render plot. So this right here, this was also another question. This is render data frame. And the other question is, yes, I believe Shiny works with Norwals, which means like you can put in any data frame-like object, and Shiny will be able to render it in here. Your Python code itself can handle polars code, for example, and Shiny will do the polars thing. And if you need to display the data frame or the data, it's right here. Or if you just need the output from polars, then you have a little calculation box there. We'll work with Plotly. So here's a little Plotly figure. So instead of a static figure, this is a more interactive figure. This is using the SciPy widget system to get this into Shiny. So you can, all of those other features with maps or interactive plots, you can do that with Shiny. And then down here is a visualization that is built on top of Plotly called ridgeplot. So you can have some other plotting library object down here as well. The trick is you may need to know like where this thing is coming from. So like looking at the ridgeplot documentation, I think they said something like, yeah, it's a Plotly thing. So okay, we know it's a Plotly thing. Once you know it's a Plotly thing, you know it's an SciPy widgets thing, and then it's okay, at render SciPy widget, and essentially that's what's going to happen. So let's talk about all the different parts on this page. You have actually a title, which I like also totally forgot, but you have a title. Here's the little component that you can use. There's a title parameter to set it. We have a sidebar, so I'll show you how we can put together a sidebar. At the very top, we had 3 cards or 3 value boxes, and it took up the entire width of the dashboard. So we can put in these different value boxes, we can put in placeholder text for at our initial go, and then we can put them in a little like bounding box, which is what's given to you when you use a value box. We also have a full width column underneath that has 2 cards, one for a data frame, one for the scatter plot, and then the last thing is we have a whole thing at the bottom. So those are the 5 big components on this particular application, and we'll go and draft this application in the next hour. Okay, so I might skip this your turn because there's like I might skip this slide. If you have access to the slide, here are all of the documentation pages for all the components that I just talked about. But what I want to do is give you about 5 minutes to work on, let me not start the clock, to work on this particular app. Again, when in the first hour I said like get a piece of paper out and like draw out all the components, you almost do the same thing when you're building a Shiny application as well. You'll notice that like my very first step is to identify, like translate the thing I drew on the paper to just like have them all as placeholders in the application. So I want everyone to at least try one of them. Even if you don't get the sidebar thing working and you just have a card, just put that into an application and run it. Or just get 3 of them and then we can talk about the layout parts. But that's your main goal, is to get all of the big pieces laid out onto your application. Why? Now you have like a one step closer in terms of like, if I only had this much space on the screen right now and I'm planning to put a map there, a map is not going to fit well in here, right? So you now have your code that you are running with all of the outputs and all your figures and tables and everything you want to show, that's all there. On a separate step, lay out your application just like you did on your piece of paper. And you'll get a good sense of like, is this enough space? Is this too little space? Do I need to move stuff around? Typically maps need a lot of space. And my students also find like, they realize that like, yes, if I made this a map, and it's only this much in height, that's really not enough space for a map to feel like a substantial way to interact with it. And again, because of the screen limit I have, this is also an application that scrolls up and down. And then we have our little sidebar component right here where we have a placeholder for all of our inputs. Right, so this is one of the things that I always do, which is lay everything out first and then go and see if that's enough space for what you need, so you don't end up working with dashboarding code when you're just copy and pasting giant blocks. So take 5 minutes and look at, I think if I change the thing, it's going to like restart the counter. But take 5 minutes and look at like the UI card and just put in 3 UI cards somewhere, and we'll talk more about the sidebar. Or look up the sidebar and then see if you can get a placeholder on the left-hand side and then 3 UI cards on the right. And then I will, in the meantime, give everyone the code in our Slack group on like the actual solution, just so you have this as a template, because we're just going to be building on this application moving forward. And if you are in the Slack group, you can, I just pasted like the actual solution, so you can look at the solution, type it on your own, or just copy and paste the whole thing on your end, and we'll talk about each little component in 3 minutes. All right, hopefully at the if you're trying to follow along, copy paste what you have in Slack, try to run Shiny, run on your end, and then I'm going to do the same thing as well. I want to talk a little bit about the documentation site, since I think it's working now. Everyone's downloaded all the LLM models that they need. And at the very top, under components, like I think in the next, if you're watching the recording, things might be moving around in the next couple of months or by the time the recording's up, but the components page is what we just talked about. You have all the inputs. If you scroll down, here are all the different outputs. 2 different ways to visualize a data frame. If you just need like a random image, you can do that. You'll see that, yes, matplotlib. We separate matplotlib and Seaborn because they're such, the libraries are so popular that we're just going to be super explicit. Like if this is what you're using, you can totally do that. Plotly as a placeholder for all of the SciPy widgets. Same thing with mapping. Arbitrary text. You can also write code that also returns another UI component. So that's if you're trying to have applications that react to other parts of the application and like the tools and things change. That's also something you can do with Shiny. We're not going to talk too much about it today, but that is also a thing that you can do. Value boxes is what we're going to be using for those cards at the top. And then you also have the ability to just say like, hey, just echo back whatever text I give you. So that's the output components portion. The other thing with Shiny is you can have, we'll talk about chat stuff later, but you can have like pop-up messages, like if something is, for example, if you're loading a file to the server using the file input and you want like a spinning bar or like a message at the bottom when it's done or something, those are called modals or display messages. Those are also things you can do in your application, and that's all in this little components gallery. The other part is the layouts gallery. And this is where, I also have this page open all the time. Maybe you want navigation bars at the top or bottom. Maybe you want sidebars, like the example that we have, it's sidebars on the left. You can totally put the sidebar on the right. You can also put sidebars within a card, so there's like a little bounding box around it as well. And sidebars can be open or closed, or they start off collapsed. Sometimes you might have navigation bars on the top. Maybe you want like smaller areas that have multiple tabs in there, so you have different ways to tab your output. This might be really useful if you're looking at like a machine learning model and you're just like going through different metrics, but you don't want all of the output all at once. That's one use case where you can use different cards layouts. Panels are another thing, and then the arranging is what we'll also see in a little bit, where there are ways for it to just say, take up the full width of something, or maybe the full height of something. We talk about reactive design, so like something that might work well on a phone as well. So like that's why these notion of cards come into play. It's like it knows how to reflow the entire card. So if you have an application that you want working on a mobile phone as well, but you don't want it like in the landscape view, but you have all your cards and components and it's okay to see them from top to bottom. You'll use a combination of like the grid layout with the filling, and then maybe you'll put everything into like a card without a tab or something like that. And then you'll have nice little bounding boxes. There'll be a lot of padding. That's the other thing with dashboards is like, as much as we want to convey all the information all the time, if you don't give yourself white space, it looks very busy. And as data scientists, you also want to make your output like pleasurable to the eyes, because otherwise people are not really going to look at it. And then if no one's looking at it, then like you're kind of like, why, like no matter what the insights are, no one's going to be able to see it. And I've heard from folks where, if any of you had to put reports together for like your boss or something, I've heard people say like, yeah, if my boss doesn't get the report in like Times New Roman, like he physically cannot like get past that. And that's like the only thing that you have, like they can't read anything else. Sometimes I work with other people and it's like, if the spacing's not right, like they're so fixated on that spacing that like they can't oversee it to like look at anything else. So yes, the visual aspect of a lot of dashboards and reports like really do matter. And we try to make it a little bit easier for you with all of these little components. The other thing I want to show you is on the reference tab. We're talking about Shiny Express, so you have it here. You can also look at Shiny Core. They pretty much match 1-to-1. But this is sort of one of the things that I think the Posit folks picked up from the R world is we sort of like namespace things within the module. So all of your UI components are also right here. So if you need a quick way to figure out like what all my input components are, look for UI.input_, and this is everything that you have available to you. We're working with a checkbox. Oh, not a checkbox. We are working with radio buttons. So you can also click on the radio buttons. This is the actual documentation site of the radio button instead of the component prettier with examples view. So this is always a lot more in-depth. You also have all of these output components, render.something. All of these layout components, you'll see a couple of them in the next couple of minutes. And then we'll talk about chat interfaces in the next hour. But like this documentation site really does have everything that you need. And I think even though there's a lot of parts, it's sectioned off pretty well in terms of you can generally find what you need. And I do this with the pandas documentation all the time where I open the API page and I just scroll and I look for stuff. And sometimes things are like, oh, I never learned about that before, and you kind of click in. This is slowly how you learn a little bit more and more about a particular tool. All right, so let's talk about this particular app. All right. We have a couple of exercises. I might just skip it for time and just give you the answers for everything. All right, VS Code. I'm going to create a new app. We'll call this app dashboard.py, and we'll paste it. I'll save it. I'll close this application, and I'll run it. All right, cool. So you can see a little bit of the wrapping that is going on. The cards are sort of like stacked on top of one another instead of looking at them like you do in that screenshot. So if I wanted to, I can look at the application in my web browser, and you'll see that like, yes, it actually doesn't just look like what I have in VS Code. So that's also something that's nice. Okay, so let's talk about this code line by line. Right now, we're going to still import Shiny Express. You'll notice that, like, yes, my IDE is telling me I'm not using input anything. Everything's a UI part right now, and that's okay. Again, that is my tip to everyone is just work out the UI when you're first putting together a dashboard. Separate if you're already like given a dashboard, but if you're building one, just start with the UI, have your little notebook to the side of everything you want. The first thing we're going to do is we're going to set that title, right? Remember the 5 things that we have in this application. First thing is the title. So we're going to set the page option to restaurant tipping, and then I also wanted to just take up as much horizontal space, just fill the page for the dashboard. So I can say fillable equals true, and it'll be smart enough to be like, okay, you don't really need like margins on the side. I'll make my application auto grow to the bounding space. So here's the first part that we haven't seen before. In the first example, we just said, here's the input, put it right here. Here's the output, dump it right here. In Shiny Express, this is different from in Shiny Core, since someone asked about it. Instead of having a separate area or a variable that is controlling each individual input and a separate area of your code base that's controlling all of the output, you're putting the inputs and the layout UI components. Instead of putting all the layout components in separate areas, we are using the with context manager to specify this area has this particular layout component to it. So the actual function is UI.sidebar, but we're going to say, hey, we're going to create a sidebar, and this is what I want you to put into it. So I'm going to say sidebar components the text, and so my sidebar has sidebar inputs the text. Everything else, so outside of that, is now going to be the body of the application. But if we look at our app example, our body, that first one, If you tried to put in multiple cards in the example when I said try it on your own, you probably got 3 cards that just took up the entire width, like one on top of the other instead of one next to the other. So there's another type of layout called layout_columns because we want to lay something out in a few columns. So we're going to use another context manager for that. So there's another with statement. And then in each of those columns, we have 3 value boxes. So we have a value box. Value boxes are a special entity in Shiny because if we look at a value box, or if you look at the original dashboard, there's a label here, there's a value here, and then there's also an image off to the side. So a value box is a special type of UI element that sort of accentuates, like, here's a thing that you can visualize. So value boxes technically come with their own context manager. Not every single UI element will have its own context manager like a value box. But again, that is also why I have said, come to the documentation site, and you will, in general, have like the code to get you started with that particular application. And again, we talked about Shiny Live. This is running in Shiny Live. You can literally copy and paste this into Shiny Live and then run it in there. So again, Shiny Live could also be another area where you're prototyping code, and then when you get it working, like cut and paste that code back into your application as well. So we have a column, and then 3 different items in there, and then that's what will create that particular first row of values. And you can see width fillable, that's taking up the width, and also this fill false is so it doesn't take up the horizontal, I believe the vertical width. But inside this column, you'll notice that in VS Code, because I don't have that much horizontal space, it's able to reflow that section for us. Then we have our second row of cards, so it's another set of columns. And here is another scenario that we can use. I'm going to slowly introduce web technologies to you. I'm not an expert with all of the web technologies, but Shiny is built on top of Bootstrap, and Bootstrap has this 12-grid system, which is essentially saying every single website that uses Bootstrap's grid system is the width of the site, or that part, is divided up into 12 boxes. And you specify the width by saying how many of those 12 boxes you want it to take up. So, and you can subset it. So if I'm saying I'm only using half the site, it is a width of 6. But within that 6, there's another 12, right? So you can always subdivide in, but the magic number is 12. I like to believe that they picked 12 because it has a lot of factors in there. And I believe it was like, if we follow the Mesopotamians, we would be on a base 12 system. If you have 12 segments on your fingers, you can actually count by 12s. But I'm assuming that's why they picked 12. It's actually a very nice round number because of how many ways you can break it up. So here I'm saying, hey, I want a column, and I want 2 things in this column. So I'm saying 6 and 6. That's why, and 6 plus 6 equals 12. So if you see numbers like that in Shiny, it's typically referring to that 12 grid system. And really where that's all coming from is Bootstrap. So you might see it in Shiny, yes. You might see in other libraries that deal with anything web related when you're just working with spacing. The benefit of this is it helps reflow things when you have to go from screen to smaller screen to phone. It's just, everything's always 12 things wide. You don't have to specify 300 pixels, because now 300 pixels looks huge on a phone and like tiny on your on a computer screen. So that's why people try to use some other metric than like putting in hardcode widths. So in here we have a few cards, and in the card I'm going to say I want a placeholder for my data set, I want a placeholder for my scatter plot, and then we're going to have another column at the bottom that says like give me that ridge plot at the bottom. And that's it. That is my first step. I will typically go in here and like visually see like, yeah, I know the data frame is going to be a little bigger. Is that okay? You just get a general sense of like, making progress with your dashboard, and then slowly, like, oh, I actually have figures to work on. So if like my boss is asking me about stuff, I can at least give them the figure and then tell them like, hey, just imagine this in this section here, right? So that's also my tip and recommendation to a lot of people when you're building up an application like that. Okay, running a little bit behind, but we're okay. Okay, the next part is I'm going to give you all the code, but the short answer is let's go and put in those input components, right? So really similar to what we just did in that very first application. This is a slider with two sides. A two-sided slider is really a slider with one side with like, you pass in a list instead of a single value and it knows to make a two-sided slider. I believe that's how that works. Here, instead of a radio button, we're using a checkbox group, and it's because maybe you want the ability to select multiple. Could I have made this a selectize that selects multiple? I totally could. My general rule is if you have like 3 things, you can probably show it all on the screen, because a drop down with 3 is kind of weird sometimes. Again, depending on your the screen real estate that you have. And at the very bottom, we're not going to talk too much about the reset button yet, but you can also put in an actual action button that does other stuff, like reset these values if we need. So I'm going to give everyone the code for this, and then I'm going to run it on my computer. And again, the code is in the repository. If you navigate to the actual slide deck, it's actually in the file for the slide deck. And I will show everyone that when we get there. Towards the end, I'll show everyone how you can access everything. So all I did was copy paste. I put in a few more values like placeholder stuff in here. And then I add in a couple of placeholder bits of text for those cards on the bottom. And then the main takeaway is, yes, all I did was in that sidebar, we're using input slider instead of input checkbox. This is kind of how you define a slider. There's always an ID. That's the thing to keep in mind. There's always an ID. And then minimum, maximum value, that is going to be dependent on what type of component you're using. I'm using a checkbox group, and so there's, again, always an ID, and then everything else is going to be dependent on the object that you're using. And then right here, it's still UI input something, but I have an action button, and I'll call it action button, and it has a title called reset filter. So I might actually call this like reset button if I want it to be, if I know that's the only thing in there. But the documentation is called an action button. And then everything else was left the same for our particular dashboard. So I'll give everyone the code for this in Slack. And then we can go on to slowly building up the next section. All right. So the next thing is let's go and add some data. Here's some code that will take in 2 placeholders that represent the index, that we read from the index. And then we, at the end of the day, get this filter data set at the bottom, right? So this is regular pandas code that we're going to say, hey, I know I'm going to have a placeholder for like the lower bound of that slider, the upper bound of that slider, and then the what is selected from that checkbox group, right? So I'm doing the same technique that I showed before, which is refactor like some of your code such that you try to get it into like variable to input, and then write the code down here that will go and subset this. There's many different techniques on like if you have multiple ways to filter, how do you chain filter something? I believe this is what ChatGPT or Claude gave me. I was like, wait, that's actually way better than what I was going to do, so I ended up sticking with it. So you created one index of true-false values, you create another one, and then you just like intersect them all together and you filter it. I was like, that is definitely way better than what I was going to come up with. So that is our code for filtering our data, and I'll go through this and then just give everyone the actual solution at the end. The other thing, when you're slowly building up your like notebook that accompanies your dashboard, like actually go and like compute like the things that you want to show up in there, right? So I have the total number of tippers. Like, what is the code that generates that? Well, it's like the shape and then get the first value that represents the number of rows. The average tip, I'm going to take whatever my filter data set is and like divide it by tip by total bill, and then maybe I do some fancy string formatting to get a percentage, because that's what I want as a render text output. Same thing with average bill. I'm going to write my regular pandas, polars, whatever code to calculate the average, and then maybe if I need some string formatting, like I need 2 decimal points, yes, just write the code in your little notebook, and now this code is ready to be put into the dashboard. It's just not in the dashboard yet. Same thing with the scatter plot. Here's my Plotly Express plot, and there you go, scatter plot. Great. The ridge plot itself is a little bit more complicated. This is why I'm also like, this is not a plotting class. Ridge plot itself, like you can use other libraries for this as well, but here's just the plot for a ridge plot, and like I didn't even bother trying to like fit it on the page or anything, but you can, it's a ridge plot. But again, the main takeaway is you'll see that I'm setting the orientation, I'm setting like where the, what is this called? The legend, where the legend shows up. Like again, do a lot of that configuring before you dump things into the dashboard, such that this just becomes a cut and paste when you get to that point. Okay, so we will talk about this part. I'll take a little break. I think it's okay that we are sort of running on time because the next part is about LLMs, and that's mostly just like me talking at you. But the next thing is we'll break here, but I'll talk about the sort of problem, and then we'll address the problem and solve it. We'll use the same techniques to get all of those values into our value box. So we have our little slider. So this is all of our UI components, right? And then once we get past the UI, we have the body of our application, we have our layout, and then we have our value box. We have our title called total tippers. And then in here, we're gonna say like, hey, I actually want you to calculate something to show up in that value box, right? So that's why like that slide that I had before that just pre-calculated all the values is really important. And so if I look at the code for the first 2 value boxes right here, you might notice that yes, I am subsetting the data, even syntax highlights. I'm subsetting the data set multiple times, right? That means that each one of these cards, when it's showing that display, is rereading that input from the input and doing its own subset and calculation that way, right? So I'll leave this code right here just so we can have time for a break, and then we'll talk about how to address this problem. We saw how we addressed this problem in that reactivity graph where I said like, hey, there's this intermediate sample that's being calculated, so we'll show you how we actually end up doing that in our code base. But if you didn't know how like that was a feature, this is kind of like what you can do, and you can see the app still works. It's just not as efficient. And so you can always make something that works and slowly work and refactor things to make things more efficient. So if this is the first way you write your application, totally fine. You can always go back and like replace it with a variable. So we'll take a slightly shorter break to make up on time, but come back at the bottom of the hour at 3:15 local time, and then we'll keep going with this example and just build out this entire application. It is 3:24, so come back. Did I say 3:20? Come back in 5 minutes. Bottom of the hour. There we go. Give me 1 second, and then let me. All right, bottom of the hour, and we'll talk about it. Okay, so we left off talking about, yes, each of those cards, or those value boxes, not a card, each of those value boxes, when we were asking it to show the whatever value you're interested in showing, it was doing this: get the value for the slider, get the value from the checkbox, go and filter the data set, and then go and do your calculation. That was happening 3 times in our code. If you think about the little reactive graph, what's happening is you have 3 outputs that you're asking the model to calculate, and it's pulling in from, like, each one of those outputs is pulling in from the input. So it looks, even visually as a graph, it looks really messy. It would be nice if we said, hey, if we took this tips filtered and we just saved it into a data frame and then use that filter data frame in all of the other downstream outputs. That's one way where, one, we can definitely reduce the amount of copy and pasting in our code. And then 2, if you think about what I showed you in that reactive graph part, it doesn't have to go and refilter your data set 3 different times for each of those 3 value boxes. So the way we handle that is, in Shiny, there is another thing. This is another new thing that we're going to talk about, is you have this reactive calculation object that you can create. So you have inputs, you have outputs, and then if there's like some type of thing in the middle you kind of just want to save as like an intermediate value, you can use reactive.calc as a reactive calculation. One of the things is reactive is a part of like the core of Shiny. So you do have to say from Shiny import reactive. That was a very conscious decision by the engineers that like actually tell you it is the same reactive framework in Shiny Core or Express or just Shiny in general. So the import, we have to add another thing to the import. But all we do is we create another object called reactive calc. And then this object, because it's not an input, it's not an output, it's like this thing in the middle, you'll notice that like I don't, like this thing, this part here as an intermediate calculation doesn't really show up on the website, on the application anywhere. It's an intermediate thing. You didn't tell it how to render it. So here's an example of an application. It's got an input slider at the top, and we have a render text. So instead of render plot or widget or something like that, I'm just saying pull in the value from input X and then just show me that value. So like if I scroll this thing, yes, it's like reading that number. What you can also do is if you have a more complicated calculation, you can save this as a reactive calc. So right here I'm using reactive.calc. I have x squared, and then this object, right now it's going to be I'm assuming it's an integer. It might come in as a float, but I don't think so. There's no decimal point. But this integer is going to be saved as x squared. And then the way I use it is just saying x squared parenthesis, like go and call that function. And again, by calling this function, it is building that reactive graph. This is the magic of Shiny, is like once you told me to show you this number, it's going to run this code, and it says go run x squared. And I'm going to go and run x squared. X squared, it says go look up x, and then it's going to look up this value from this slider, and then this value is saved as x squared. All right, so it only needs to calculate it once. If I need to use it multiple times in my application, as long as the input doesn't change, it's not invalidated, and so it will just return that cached value. So same thing applies. We can do a reactive calc, and instead of returning an integer, we can say return a data frame. And now any part of the application that is reliant on that filtered data frame, we can just call it with the, don't forget the round parentheses. Like I keep bringing that up because that is like also, I forget that all the time. The error message you'll get will be something along the lines of like, I can't do this with this reactive object. Like the parentheses actually returns you the calculated result. So that's essentially how we're going to modify our application by saying, hey, we're going to just take that filter data frame, make it a reactive calculation, and then everything else will be based off of that intermediate value. You'll notice here that like even though that I'm squaring something 3 times, it only shows up twice because this reactive calc, even though it shows up in between these 2 text boxes, it's not a render anything, right? Like there's nothing there that says like show the output to the page. You can write print statements and it'll show up in like the console log or something like that, but it's not going to be rendered on to the page. You have to make an explicit render call. So this is something that also happens a lot when I'm trying to debug something where like I have a render calc somewhere and then it's just like, what is happening with my dashboard? I'm either printing it or I'm like creating a temporary render output that just dumps me what I see. Something that I've done in the past is in my dashboard application, I'll have like a, what is it, like a log panel. Like I'll use the UI panel, make a log panel on the side, and a lot of those intermediate calculations, I'll just use that as a placeholder to dump out like all of my reactive calc outputs. So as I'm building my app, I can actually visually see that things are changing as I need. So that's something that I've done in the past where you just have like a developer console view of like what's happening. Again, that's not really causing extra calculations because if it's already visualized on the screen once, it's just pulling that cached value. So we're going to do the same technique with our reactive, oh wait, is this the, okay, I think I'm build on square, yeah, okay. As another example, what this is also doing is your reactive calc, I think I'm using it. Actually, never mind. I guess I like screwed up this demo. But you can build on top of another reactive calc, right? So like if you have a reactive calc that's like a filtered data frame and you have, you're doing, like I need a subset for each of the another component, you can definitely build on top of reactive calculations. And again, the magic of Shiny is that it kind of just knows all these objects are there, and then reactively it will figure out how to recompute them. So that's sort of the nice thing. Like you can start to see like if you have to manually keep track of all of this, it gets really cumbersome. Versus let me just use the thing I just made because you can find functions that way and reactive calcs that way. A lot of IDEs also allow you to collapse your code. So I end up doing that a lot as well because Shiny code or dashboarding code or web code in general just can balloon very, very quickly. Okay, so I say it's your turn. I'm going to give myself 5 minutes to like just do this. But what we're going to do is, this is the baseline solution. What I am going to do is just put in the answer. Actually, yeah, I'll just put in the answer to the full application. And we'll talk about the full application answer. Okay. And I'll put the full application answer in Slack. It's also in the it's also on the website as well. Okay, so I have the rich plot put in there. I have the plotly stuff put in there. So like, and Seaborn is for the data set. We have Shiny Express. We are doing some reactive stuff. This is the magic for anytime you're working with any of those SciPy widget outputs. There's render plotly, I think there's render altair, but there's also, in general, there's a render widget option. So if you're pulling some SciPy leaflet, I think that's just render widget or something like that. So it's pretty flexible in that sense. And Carson from the Shine team really worked hard to make sure that it's compatible with all of the other Jupyter tools as well for those visualizations. So let's talk about this app. We have our title, we have our UI sidebar. It has the bill amount, the checkbox group, and the action button, so none of that has changed. And now you see we have a reactive calc. And this index 1, index 2, union, is it union? Intersect those things together to filter, to return tips filtered. This return type is tips filter, but the function is called filter underscore data. So that means that anytime I want to use this reactive filtered data set, I call filtered underscore data. And so right here, where this all became index 1, index 2, intersect, return, I can just say, just take that data set, give me the first value of the shape, which is the number of rows, right? So not only have I reduced the amount of lines in this part of the code, I've completely gotten rid of the duplicate of that subsetting feature in my code base. Right, so that was card 1. Card 2, yes, I needed to calculate tip divided by total bill to get the percentage and then some string formatting. But again, all of that index 1, index 2, intersect is no longer part of that value box anymore. Same with calculating average bill. All I'm doing is using that reactive calc and moving forward from there. Other things you can do is maybe you want to reactively render text for like the title. You can totally save like the bill to another reactive calc, and then maybe that bill value shows up elsewhere in your code. That's totally a valid thing to do. So there's nothing wrong with just saying, I'm just going to have a reactive calc and it's just one value. That's totally okay. The whole premise is Shiny will update that value. It will invalidate and recalculate as needed. And then you use your normal good Python coding hygiene of let's not repeat our code with copying and pasting things over and over and over again. So it really does, reactive calc does solve that problem of reducing the duplicate in your code, which also means your dashboard will run a little bit faster because it's not recomputing something over and over again. Our other parts, so right here, this is a different render output that you've seen, but it's the same thing. Render instead of text, instead of render figure, instead of render plotly, we're saying render data frame, and all I'm doing is like, here's a data frame, go and render it. I'm not doing anything fancy. You could totally do something fancy with the render data frame type, but I'm just saying in this particular example, let's just give you the data frame. So again, there's also nothing wrong with a one-liner that says, reactive calc, show the reactive calc. That's literally what I'm doing right here. For our scatter plot, the code that I showed you in the slide deck is exactly the same. I'm just changing the variable for that data frame. Instead of like tips filtered, I'm using the reactive value for filter data set now. And then the rest of the plotting code, again, is exactly the same. Same with this ridge plot. I am using filtered underscore data and making sure I'm like replacing it in all of the places. But then this was just, that ridge plot just had a lot of code into it. And don't forget to return the actual plotting value. The ridge plot itself is using render underscore widget. And then you can also use render underscore plotly. I believe plotly would also work for render widget. But in this example, it's mostly just to show you that if you don't know what type of SciPy widget it is, you can always use render widget. And also the syntax is a little bit different because it's coming from a different different Python package with all of the SciPy widget support. So it's render underscore plotly, not render dot plotly. So there might be some typos that you make. This is a pretty subtle one. And if we go and run this, and it's picking 5921, let it go do its thing. And let me give you a nice bigger view of it. Here's our dashboard. We have our render table, we have our scatter plot, we got our ridge plot down here, we got our 3 values at the top, and then now if the slider changes, you'll see things kind of jumping around. And again, all this is doing is actually just changing the value here, this data frame, and then everything else is really dependent on this data frame input, right? And think about your own data sets. It's not limited to one data frame. You can have multiple data frames. Maybe you have one slider, filter one data frame, another slider, filter another, and then you have a reactive calc that does the joining. That's totally a valid technique as well. And that's a type of data cleaning that you have to do in the dashboard, right? Like you're asking the user to interactively filter so that you can interactively or reactively filter or join those 2 tables. That's something you would have to do in the dashboard. But if it's two separate data sets. Like sometimes, what is it, like sometimes you might have a recoding data frame just to help you recode values. I would just make sure that data is already in there in the dashboard so you're not unnecessarily joining tables or something like that. Okay, cool. So that's our example of a more complicated application. It brought out a lot of new things. So you have some idea of a layout, you have cards, we talked about column layouts, we talked about the CSS bootstrap grid system, we talked about reactive calculations, so you're not just one-to-one, and all of these are using different cards, so we can have a little bit more like white space. If you don't like it, you don't have to use a card, but that's sort of one of the things that I guess the team has decided is like the more you can wrap things around cards, you have like a nice little drop shadow. It just helps pop out certain elements. Totally up to you and what you need, because sometimes it does do a little bit too much white space padding, so that's really up to you if you need that in your application or not. But those types of layout components are all available to you. We haven't talked about the reset filter, not in this particular class. After this course, I'll give you the answer for this reset filter button. It's using a totally separate, not a totally separate, there's another mechanism which is called, I forgot, you use the ID of the component, and there's I think it's like UI.update. There's like an update function that you use. And so this is now a special button that when you click on a button, it creates a side effect. It's just doing something else. It's not necessarily an input or an output. It's just changing an existing input. So that's also another feature that you can do, and it has to do with like button clicks. But that's our first application. It's building on top of the same concepts that we talked about in our penguins example, but a little bit more worked out, so hopefully this gives you a little bit more inspiration for whatever dashboard that you're looking into. Okay, cool. So next, let us talk about some LLM stuff, and that's kind of like the thing everyone's talking about these days. That's okay, that image doesn't really matter too much. But Joe Chang, he's giving a talk here about some of the scientific implications and how can we make LLMs work better for us as researchers and scientists. He's giving a talk on tomorrow. There's a talk tomorrow that Joe is giving. He also gave like a 40-minute webinar talk about what I'm talking about today, what he's talking about tomorrow. There's like a way more worked out version that you can click on that YouTube link. But we'll talk about some of these questions. Who here has just used ChatGPT? If you're like my students, it's really everyone, and if you didn't raise your hand, you're probably a liar, but. But who here is like pretty skeptical about them? Yeah, I think I was as well. For those who are skeptical, I'm assuming, oops. I'm assuming it's because your interaction with it has been primarily around like the desktop app of like ChatGPT or like Claude Code or something like, or Claude. Has anyone actually worked with an LLM like through code, like in Python, for example, like coding against it with the API? Is that anyone? Like a few? Okay. So we'll talk about coding against it with the API, and then literally show you how you can incorporate that into a dashboard and then put in like some guardrails around that as well. And again, with LLMs, like unless you're using a local llama model, like don't just dump stuff. Like your IT folks are probably not gonna be very happy if you go and do that. So don't do that. Okay, so we are going to first talk about the anatomy of a conversation. How does a conversation between us and a chatbot actually work? A conversation is really a sequence of HTTP requests. There's a server, and it is entirely stateless. That is a keyword, and I'll talk to you about the ramifications from that in a little bit. But you talk to a server, and it gives you back a response, and then you re-ask another question, you talk to a server, and it gives you back another response. And it's entirely stateless in that the server, like when you make the second request, technically doesn't know that you had a previous line of conversation with it, which is not how we interact as humans, but it is actually how it interacts with the LLM, even though it seems like it somehow remembers stuff. But at the end of the day, everything is an HTTP request, and the server that you're talking to, whether it's OpenAI or Anthropic or Google, is entirely stateless. So if we have a conversation and we say, what is the capital of the moon? You get a response, there isn't one. And if you say, are you sure? The response will be something like, yes, I'm sure, right? And this seems like there's this concept of memory, but I just said it's stateless. There's actually no concept of memory going on. So in the HTTP request, the way this works is you have some role, there's a system prompt, right? So this is the prompt that a lot of people talk about that is specific to the LLM, and you don't necessarily, when you're talking with it, have the ability to change it. But then you are able to ask a question, what is the capital of the moon? And you'll notice that this comes from the actual user. So it's able to keep track of who is saying what the rules are, what the model you have is, and then your API key or stuff like that. So you can specify the model, here's the components, and there we go. And then you get a response back. The response, there's a specific type of role called assistant, and it'll be like, the moon doesn't have a capital, and that's the answer that you actually get back. Other things that you'll say is why did the answer stop? It's because, well, it just stopped, that's it. Other reasons why it would stop is you ran out of money, and I ran out of tokens, so if you want me to give you more words, give me more money, is sort of another type of reason. Other things, LLMs are highly dependent on what's known as a token. It's almost like a word, and essentially you're paying for the number of token transactions. And so when you go and ask a follow-up question, how does the moon, the assistant goes no, it doesn't really have a thing, and you say, are you sure? You'll notice that when you type in, are you sure, this is the entire payload. The conversation history actually went with it. And what that means is if you actually look at the response and it's the assistant is this, and you look at the number of tokens, it went from 20, it went from a really small number to a fairly large number, and it doesn't seem like it made, clearly that number jumped higher than what you would expect if it was remembering stuff along the way. And it's because when you go ask the follow-up question, literally all the history went with the follow-up question. That's why the token number sort of, I don't know if it's exponential growth, but it grows the longer and longer you have your conversation. And that's, in general, how all LLMs work. There's techniques that people are coming up with that try to cache things, but as far as this class goes, that's how it works. Which is kind of scary. You're going from 12 and you ask a follow-up question, and it went from 67, you're that doesn't make sense. It's a literal scam. That's what's happening. So tokens, the fundamental unit of pricing and how things work are on tokens. So for example, what is the capital of the moon? It gets broken up into a sequence of numbers which represent a token. Internally, it's all doing math, transformer math. So that's 8 pieces of tokens. Other words like counter-revolutionary will get broken up into 4 tokens, and then you're being paid on that. All my links are broken. That's terrible. Everything is based off of pricing. So for Claude Sonnet, you are given whatever tier that you're paying for, at that mid-tier level, you're allowed about 3 million input tokens, 50, $3 for 1,000,000 tokens, $15 for 1,000,000 output tokens. There we go. And there's also what's known as a context window. So when you are having that back and forth conversation and that entire payload of conversation is happening, that is the context window. So models have, that's why sometimes when you have a conversation with ChatGPT, it just says like, I have no more space. It's because your conversation lasted too long. It's either you asked it to give you too many things and it's part of the context window, or or your conversation just lasted way too long. So those are sort of the key vocabulary words. Different models have different context windows, so you can, like, for example, this is a general sense of how large context windows can be. I'm in the very slow process of reading Scherbach, and that's about 67,000 words. So it's about 60, maybe 80,000 tokens, and that is like the context window. So when you're talking about giving it, like feeding it the documentation, so I can ask more questions about the documentation, that is all part of the context window. You're just feeding it that information. Okay. That is how chats work. Again, the key part is everything is stateless. So let's talk about getting our first application working. There's a bunch of different providers. So we have OpenAI, which makes ChatGPT, Anthropic, Google, X, Meta, which makes Llama. The Llama models are really popular because it is completely local on your computer. So as long as you have the disk space somewhere, you can have that model and it's not connecting to the internet somewhere. So that's sort of why a lot of talks, I think Eric Ma gave a workshop yesterday about LLMs. That is why, like, his workshop, I think, is using Llama models. It's because it's local and it's not going anywhere, and Eric works for pharma, so they don't really want their stuff going out into the public for no reason. So here's some code. I can run it for you, but I just want to just generally talk about how do we actually code against this stuff. So for OpenAI, and you can take this code and run it if you want, assuming you have the API keys. For OpenAI, you create a client. And then here is literally the code that sets up, like, what is your system prompt? And then here is like the user prompt, like I type this in and say, what is the capital of the moon? And it will give me a response back, and I can go and print this response if I want to. And if I want to ask a follow-up question, here's why sometimes working with this stuff is a bit cumbersome. You have to, when you go and ask a follow-up response, because everything is stateless, you have to construct that history together to go and ask that follow-up response, right? So when I ask you, are you sure, it comes with the, what is the capital of the moon? No, the moon doesn't have a capital. Like, that text needs to be in that payload. That HTTP request has to be in there. What that means is you, as the Python programmer, you have to sort of handle and stitch everything together. Another thing that you can do, if part of the setup instructions was around setting up a GitHub token, and it's because you can use GitHub models to actually use and connect to OpenAI and have a free way to access, like, the latest models, which is a really nice thing when you're prototyping small applications. There are rate limits to them, but it's better than, like, putting in a credit card to do anything. You can just do something right now, and if you're like, okay, I've ran out of, like, credits for this hour, this seems like it works, like, maybe I can now go and use this as a demo, like, and show it off, and then, like, get money from, like, other people that are willing to pay for this thing, right? So GitHub models, I would say, it's not new, but I recently discovered it, and it sort of made a lot of these workshops and tutorials a lot more useful, because anyone here, as long as you set the GitHub_token environment variable, you have access to all of those other models that GitHub has. So don't let the cost of using any of these models be any barrier, and I very much implore, like, everyone to try this stuff out. We are not going to do this. So the whole point of this is the folks at Posit and Carson, who's going to be here in an hour, he wrote a package called Chatless. And one of the main premise of Chatless is when you go and ask for that follow-up response, and you just say, chat, are you sure, as a second follow-up response, internally it's appending the message for you, just for you. So like, yes, you have all of the control with OpenAI and like LangChain and all of those. Those are all frameworks on how you can talk with a chat bot or an LLM or the API. But for the most part, many of our use cases is I just have a follow-up question. Like I don't need all of that manual control infrastructure. And so Chatless, one of the ways that you can work with Chatless is you're saying, well, this chat object will keep track of the history for you, and when you ask for a follow-up question, it will just append it and resubmit it for you, which is really cool. You'll notice, like just looking at the number of lines of code, like that's it, right? And so I will prove this to you, and I'm kind of hoping that like, uh-oh. I meant to copy this. Okay. Don't need this for this demo. All right. So I am using ChatGPT. The model is 4.1, and then the system prompt is you are Terse assistant, and I can say what is the capital of the moon, and it will give me that answer, and I can just say are you sure, and it just like no more of like appending and all of that, which is really, really nice. And if I really need to, you have access to this chat object, and you can see like here's like that JSON response, and I'm afraid to scroll up anymore because there might be an API key that gets exposed, but you do have access to all of those components. So what is also really nice is because of OpenAI and how popular that API is, a lot of other tools will model the OpenAI API interface, but you still have access to that JSON underlying information. So if you need to work within a more custom way, you totally could. Okay, I promise this will get somewhere. Okay. So a cool demo that I have is where did it go? Okay, here it is. There is a demo in here called 20 questions, and this is just to test your like understanding. The example's written in R, but I don't think it matters. But there's some cool stuff in here, and this is sort of why I just wanted to provide some space to bring up why Chatless is also a really cool tool. So let's play 20 questions. Think of an object, and we'll have the thing respond. Do you fit in a pocket? All right. Who's got a guess? Okay. Who's got an idea? Are you? That's not even good English. Are you all right? Is it two T's? Writing. Oh. Are you okay? Okay, cool. Great. It's getting real dicey there. But this is application actually, like, yes, that's 20 questions, all whatever. But actually, the application is written in such a way just to prove one point, which is if we actually look at what actually is the model used behind each interaction, it is flipping between a totally different LLM model during each conversation. Why does this work? Again, it's because it's stateless and the entire history is getting payloaded through each interaction, right? So this application, less about, yes, it's a Shiny app technically, but it's really just to also drill the point that like these things are stateless. You can capture the full conversation just by just getting the information from that last bit of whatever the last response is. The other thing in this particular code base, which I sort of skipped over all of the R parts, but where is it? Here's an example of a system prompt. So this is asking it, like, here are all the rules for playing the game. That's how that works. But instead of Elmer, pretend this says chatless. But that's also one of the really nice things about chatless is there's a separate function that gives you a chat object that allows you to connect to all of those other API tools, API endpoints, or all those other chat endpoints. So it's less about OpenAI being the best or Anthropic being best. The Shiny team, or really Carson, really made it easy for you to just try out a lot of things. And as scientists, like the more tools you are given to be able to try out a lot of things to see what works for your use case, like that's sort of what scientific exploration is, or a part of it. And so this is one of those tools that I want to bring up because it really does make it easy to try new things. You can do the same thing with llama models. Like, yes, you can download the 250 gigabyte model. That's great. It's 250 gigabytes. You might not have that much space on your computer. So could you work with a smaller prototype on your laptop and then in deployment work on a different model? Yes, it makes this operation much easier. Could you use one of the free GitHub models and then compare the ChatGPT 4.1 to a llama model? It is literally changing the parameter of that chat initialization feature there. So you have a lot of flexibility to change different objects from one another. And then the chat object, when you talk to another system, it will just reformat whatever payload it needs to just to be able to have a conversation with that. So this tool is less about telling you which tool is the best, but it's really just giving you a much nicer interface to work with these other tools. And also, like, yes, we're at SciPy, it is an open source tool, so it's not like you're paying for chatless or anything. If anything, you're paying for the API key. I never see any of that, right? So, okay, so why did I end up bringing all of this into this particular workshop? It's because, well, this thing that we just interacted with was a Shiny app. And so how do we go and build a Shiny app like this? And then the next part is, how do we build a Shiny app that has a chat interface that actually can work with data without it just hallucinating and making stuff up, right? Like that's also one of the things that I think is pretty valuable for us to see and understand. I think that is my next slide deck. All right. So I think this one is going to be, like, I'll show you something and then we'll talk about the code. A lot of it does, essentially what's going to happen is we just have another input component instead of all the ones that we found on the Shiny for Python site. Not necessarily chatless, but you'll get another input component that you can put into your Shiny dashboard, and then you can have that conversation, and then we'll build on that to say, how can we make the app give us a conversation that is more data friendly and work from there. Okay, so there's two different tools that we can work with. If you're coming from the R world, there is a package called Shiny Chat. If you're coming from Python, it is also a package called Shiny Chat. It's the same name, but it works in both languages. And they both will connect to Shiny for R or Shiny for Python. So here's Shiny Chat in a Python application. We have a Shiny Chat import, but the rest is the same Shiny application that we've seen before. So we have a title. We have to go and create the chat object, and here we're saying, here's the ID. And then I think by default it is set for, I think Anthropic, but you can point it to a GitHub model. And then we say like, hey, show us the UI part of the app. And then the rest of it is code to display the actual chat application component. So let me just run the code there, and then we'll see it in action, which I believe that will make a lot more sense. So workshop, we'll create a new one. We'll call this section 3. We'll call this llm.py. It is literally a problem I think many of you just had, which is it needs to begin with app if I want to use the play button. Okay. Oh yeah, so this part down here is just content just to show you what the payload information is. Right, so this chat application, I think, doesn't do anything important. I think it just echoes back what I have said. So we're going to say, hello, class. It's just going to say, like, you said hello, class, right? But this is the core component of having a chat interface into a Shiny app, which is create the actual chat interface and then use chat.ui to get the little chat like thing where the user can type and then the conversation output happening. That is the whole crux of having a chat component into your application. So now the question is, how do we leverage this information to work with our data? So in my like 20-minute way of like telling you everything there is to know about how chat apps work, one of the things that I've also said was the system prompt is the command that you don't really get to tweak when you're having the conversation, but when you're programming with the chat application, you can provide a system prompt. And that system prompt is the instructions and steps you give the chat bot to say, like, these are your rules, please follow these rules. That's why in the 20 questions app, like there was that block of text that said, you only play 20 questions. If someone asks you to like write some Python code, just say like, that's not part of the game, and like just ask for a follow-up question, right? Like you literally have to type those instructions out. Those instructions go into the system prompt section of the chat app. There's only a couple places you can modify a chat application. It's the system prompt or like your question to it in chat. There's other things, techniques like RAG and all of that. At the end of the day, it's like you're either modifying the system prompt, you're modifying the conversation, or you're doing something with the context window, which is what RAG is trying to do. But that's it. There's only a couple places you can ever tweak or fiddle with a chat application. So if you get a little bit overwhelmed with all of the cool features or the hype of what's going on, just remember everything's stateless. There's only a couple places that people really have access to tweak, and that's really the crux of it all. So on top of Shiny Chat, which is a general, like you have a conversation with it, what we've done is we've modified the system prompt such that it works better with data. And what Query Chat actually does is you feed it a data frame, and it will go column by column, figure out the data type of the column, and create essentially like the schema of your data frame. And then all of that information gets put into the system prompt. So that's step one. Your chatbot now knows some information about your data. whether or not this is a categorical variable. If it's categorical and there's, I think like by default, if there's less than 10 unique observations, yes, the bot will know about all 10 unique observations, but if it's more, it'll treat it like a string. If it's a number, it'll know like, is it an integer or a float? And then know the upper and lower bounds of it. So that's the information that the chatbot has access to. The other thing that makes query chat really different is in the system prompt, we then say, the only thing that you are able to give back to us is SQL. Like you have to, anytime we ask you to say like, filter my data set, you have to give me the SQL command that tells me how to filter that data set. Or if you need to do some calculation, SQL is pretty powerful. You can actually ask it for like, calculate outliers by using like 3 times the IQR. And like there is an actual IQR function in SQL. And so you can get really far with just limiting its response to just SQL. And that's essentially what query chat is doing, is instead of that little side panel that opens and closes and you put in a filter, a slider, a checkbox, or all of that, if you replace it with a chatbot and you tell this chatbot the only thing you can do is speak in SQL, essentially I can take that SQL statement and through DuckDB or through pandas or through narwhals, run SQL against it, just like that tips dashboard that we just had. Everything reacted to that one data frame. So once SQL is able to filter the data frame, the entire application can filter. And that's really cool because you give the user all the flexibility to specify how they want to filter a data set through natural language. And it also frees you as the developer of like, what happens if you have 50 columns? Are you gonna put in 50 like sliders in there? Like that looks really bad. I've tried it. It looks pretty bad. It never looks really good. The other thing is, you saw it even in the example code with the tips data set, the dashboard was, if I had 2 different filters and I wanted to filter the data set, it was an and operator. It's either like all of this range or only this. Like there's no way to say any more complex type of logic. But if you're specifying in natural language, you can totally do that. You can say, give me the top 10, and you don't have to figure out what the range is for top 10, right? SQL can go and figure out, like, calculate the percentage, give you the top 10 results, right? Like limit 10, like that's how you get the top 10, right? So you now have this ability to like, yeah, all of those controls that we just talked about for the first 2 hours can, in theory, be replaced with a chatbot, and then you constrain it to only speak in SQL given this data schema that you have. And so we'll work with this particular application, and you'll see it in practice. We're using query chat. We're using chatlist to talk to, I guess in this case, Anthropic, but you can be GitHub models. And then the rest of the app is really similar to what we've seen. Here's the Titanic data set. This is some setup for query chat, which is just saying like, hey, here's my Anthropic thing. There is a system prompt that's being involved. That's okay. I have to initialize it, but I am also giving you a greeting. So this is all the stuff that shows up in the chat app. And then the actual application is, here's the chat part, and then render the data frame based off of the chat. So what does this look like? And I'm just going to replace this. And I'm hoping my API keys are all set up properly. Circular import, I think that's okay. And then I'm actually on time now by just talking through the concept and then showing you a couple of demos. Uh-oh, hold on. Oh, here it is, query chat, okay. All right, cool. So this application, it's all this is, it's like small enough. Here's the UI, the chat UI, and then all I'm saying is like, you're filtering a data frame, here's the filtered data frame, right? And you can actually ask it questions like, show me those who survived. And then you'll see it's giving me the SQL. This is the thing that's really nice about limiting the context of the chatbot, is this is inspectable. You can actually see, did it actually give me the right SQL? Select star from Titanic or survive equals 1. That's about what I asked, right? So if you have any question about whether or not this is doing the right thing, it's harder to hallucinate a SQL statement, and it's easy to inspect a SQL statement. And that is sort of gives us a little bit more comfort in terms of if we want a chatbot to interact with our data, we can. And here's the data set that is filtered, and now if you need other metrics with it, you can do that. The benefit of this is now you can say stuff like, invert that, or uh-oh. What does that say? Invalid request. All messages have non-empty. Oh, okay, hold on. Show me. Oh no. Wait, start over? Oh no, I think something just like totally broke. Hold on, let's start over. Perils of live coding, showing live demos. Okay. Show me those who survived. And then invert that. No. Okay, that's not working in this example. But essentially what's going to happen is like when you say invert that, in natural language, it will realize that it's like, oh no, instead of were survive equals 1, it's survive equals 0, right? And so now you can actually have a somewhat nicer way to interact with something instead of like clicking reset, unclicking a whole bunch of stuff. I think something is broken for one reason or the other, which is not great because this is recorded. Is let me say like show me just the outliers who paid the most. Right? So in this particular case, it was like selecting the 95th percentile within like the entire group, right? So like, again, SQL is really powerful. SQL is also one of the things LLMs are really good at doing. And so you can leverage those two techniques for your actual data work. And just to round off this particular section is SciPy is not an actual package, it is a demo. But here's our tips data frame. This is exactly the same thing that we just built before. And you can show me like, show me the top tippers. And again, it's going to replace this whole sidebar with my filter objects. And it's going to say order by percent descend or something like that. And there you go, it showed me the top tippers. And then what's going to happen is, remember our code that we just worked with is our entire application was reactive to this data frame. So if we have different cards, they're going to react. Our plots are going to react just because we have this reactive calc that has been filtered using SQL from an LLM, right? That is one technique that I think we've, like when we were all, like we as the Shiny team, when we were tinkering around with LLMs, like we sort of realized that like this is a really powerful combination of techniques that work really well, especially if, which many of you are, really skeptical about LLMs. This is like one entry point into, hey, we can actually make something really useful and still have the ability to inspect this. And then now we've reduced like, if we show this to our, like anyone who's working with our data, like, you know, how many times have we been asked to do something and they're like, oh, can you also add this one other thing? And it's like simple for us, but like, oh man, that's like another 30 minutes because I have to figure out how to open the project again and like update or add another slider and then hope that it works and et cetera, et cetera, et cetera. Now we can say something like, show me just the Sunday. And then like, I don't know if it's gonna put in the previous statement with the current one, but it doesn't matter. It gave me the SQL that's saying like, okay, no, it didn't show me the top Sunday, it showed me all of Sunday, and I can inspect it. So this is like a render text of the SQL, even though that the conversation is also showing it to us, right? And again, the code itself, all it's doing is like take SQL, apply to data frame, and then that's it. The rest of the app reacts to that rendered, that reactive calc. Cool. So let's take a 5-minute break, and then I have the last section, which is how do we build modules that scale to, that help us scale our application. And I think because of the time of day, that is please sit here and listen, and then we'll talk about it. And I think the Shiny team will be here by then. So take a 5-minute break, and if you haven't done so, you can ask a question. Ask all the questions about anything. Sorry that like your question's showing up. I was hoping that it would only show us this, but come back at the bottom of the hour, and if you have questions, just post them here, and then when at the top of the next hour, we will talk about all of that. We'll go through all of the questions that people have. website. Yeah, somehow the slide deck isn't on the website. So this is rendered locally for now, but I will get the site updated. Okay, so there's another topic, and this was the reason why I think it makes more sense to just shift it off and not do live code if many of you aren't actively creating Shiny for Python applications. But there's a concept of a Shiny module that really helps with scaling your application if you have a lot of components and you want to like section off like all of this logic with all of these reactive calcs. I just needed to like kind of hide it away because it's all tied together. And maybe you have a multi-page app and you want each page to sort of like be in its own little world and reduce the clutter on any individual file. So there's this concept of similar to a Python module, which is a .py file that you import, there is a concept of a Shiny module, which can be a file that you import, but is really a way where you can hide away bits and pieces of Shiny code or reuse different components over and over again. What is a component that you might, or something that you create that's reused over and over again? A few weeks ago, I created like with my master's students, we had this project where we were working with different farms, and we're trying to measure like the productivity, like how much energy and the productivity a farm is able to provide. And we worked with one of the research labs at the University of British Columbia where we were saying, hey, we care about these metrics and here are the figures. But we had multiple farms to compare. So I had this idea of what if we treat each farm like a product of like the Apple website where you can pick like, compare your laptops together, give you the option to pick a drop down and compare multiple farms with one another. And that was a really fun idea because you can look across and you'll see the same figure or the same number across multiple farms. But I also wanted the ability to have that like compare feel where you can click on a button and it'll create another column and you can do another drop down to pick another farm. So like just like you can select 3 or 5 different Apple products that you can compare, you can select 3 or 5 different columns and then make a drop down. And so that was a really good example of a Shiny module case because one column is just being repeated over and over again. But the most important thing that I'll bring up again, that we mentioned in the first hour, was like the ID of each component is really important. The other thing I didn't mention is the ID of each component has to be unique. So I can't just like write a function that just pops in another, like all of that data again, because the ID is not going to be unique. So you need a mechanism to change the ID of something. And that has to be tied to all of the output components because you're reading it from the ID, and there's this tight coupling of inputs and outputs and the name of the ID. This is the problem that Shiny Modules tries to solve, and this is how you can scale applications, especially if there's a component or a part of the application that needs to get repeated. So here's another motivation of less of something that gets repeated, but you might have a application that just has a whole bunch of different parts, and you just want to segment off these parts away from your app. Modules are another way to sort of just, hey, this is all related to one another. All of these reactive calcs, they're all together. They don't really get used anywhere else, but I have a 3,000, 5,000 line dashboard file, and this is just really hard to maintain. How do I sort of break these things apart such that, you know, maybe the data part is in its own little like Shiny module. So you can also use modules as a way to help scale your application, which is technically part of the title of this workshop that we're getting to right now. So here is an example of an application. And I believe this works. Yeah. So nothing too fancy, but it's got a few. Oh no. Give me 1 second. Okay, so, uh-oh. Do you see? Okay, and it's not the perfect example of why we want to use modules, but we'll sort of break this part apart, this application, such that we'll convert this code into a module. And what is the thing that we want all tied together is these three filters with this particular data set. And that's something that we want traveling together in modular form. So here's our initial app. What does this app look like? So it looks like we have this input checkbox group, we have an input slider, and those are the inputs of this particular application. One of the things about this particular slide deck is I wrote all of this code in Shiny Core, so you'll have a glimpse of what Shiny Core looks like. Essentially, instead of just using like with statements and just calling UI.input checkbox group, I'm saving all of these into like a particular variable that contains all of the UI components. So it's a little bit more code because I have to wrap everything in a UI component variable or a UI variable, but everything that I just showed you with Shiny Express is the same. It's like, here's the thing I wanted to show up here, this is where it shows up. Modules aren't just tied to Shiny Core. You can use modules for Shiny Express. I just sort of said, hey, I'm not asking you to like copy or run this code, so it's okay. So in the server code, we've seen a reactive calc. In this reactive calc, it's really similar. We have some type of variable that will handle a mask. We will go apply each of the filters. So this is my original way of like find all of the, apply the filters for each of the columns. If it's a number, like do that. Otherwise, if it's a categorical, like do some other stuff, and then at the end of the day, just return my filter data frame and then show it. So multiple ways where you can say like, take in all of the components of the input and then apply those filters to our data frame. So one of the ways that we can do it is write a for loop to create all of the UI elements. So what are we trying to do right now? What we're trying to do is for each of the columns in my data frame, for each of the columns in my data frame, if it's a number, I want you to create a slider. If it's a categorical variable, I want you to go and create a checkbox group. And so one way that you can do it is I have a list of things. I want you to iterate through this list and then go and create that list from it. So I've sectioned off like the most important parts is, hey, I have all of my filters and I'm gonna go through each one of my columns and I'm going to look at the type of that particular column, and if it's a number, return a slider. If it's not a number, return a checkbox group. And one of the things you'll also see is like I am setting the filter, the ID to be filter underscore column name. And it's like my kind of way of saying I am assuming that each of the variable names or the columns in my data set are going to be unique and I don't have two of the same column names. And I'm going to use that as the ID of my UI component. But what happens if we need to track more information, which is we need to also track the kind of filter, not just if it's a number, make it a slider. So for example, what happens if I need to know, no, I really want this to be a two-way slider because that's the range that I'm going for versus like this only makes sense if it's an individual number. So now I'm trying to track not just the column name, which then feeds into the ID. I now need to track some other variable that is like a piece of metadata on that column, right? And so you can do that. You can sort of write it out as a list comprehension, and then now you have all of the pieces of information sort of traveling together one at a time to go in reactively or dynamically create the inputs that you need. So when you need to do something like that, what you need to do is, this is a part that we didn't really talk about today until now, which is you can actually write code that generates user inputs and then use that dynamically generated user input as the actual input in your code. It's like kind of meta in that sense, where instead of saying like, I want a checkbox right here and checkbox shows up, you can actually write some type of reactive code that says, if this happens, put in a checkbox. If that happens, put in a slider, and use that return object as something that shows up as the input component in your application. So in Shiny Express, anything that was like an @render is essentially server code. So you can actually say like, hey, I want to generate a piece of UI. That's what gets reactively generated. And then I just want you to put that right there. So you can also do that in Shiny as well. Again, that example we didn't really cover in our tips or our Penguins example, but that is another really good use case where, yeah, like if you're asking a user to upload a data frame, you probably want different things showing up on the screen depending on, if you're working with, maybe they submit what's a good example? I don't have a good example off the top of my head. What happens if your dashboard accepts like two different types of machine generated output, and it's like one is from like machine A and one is from machine B? You can go and figure out what data set is coming from what machine. Maybe it's that simple as counting the number of rows, and then that governs like the entire what application layout gets loaded. So that is something that you can do with this render UI component is, hey, when I get this output, render all of this other stuff in one way versus another. So there's a couple ways that we can, when we are trying to create a whole bunch of UI elements, you can use a for loop to create the input components. You can use a for loop to read the input components. You can use a for loop to place the input component somewhere. You could define a helper function that essentially uses a for loop to put stuff there, or you could dynamically render it with something like render.ui. But, and then in our particular use case, when we are looking at a data frame, we want to track the column name, the label, the column type, and then like the actual input components. We're like trying to track 4 things all at once. So whenever you have that situation where you're like, hey, I'm trying to dynamically create something on my dashboard, and then like I'm also now trying to keep track of a whole bunch of stuff, that should be, when you get to that point in writing a Shiny app, take a pause, and that's going to be, come back to this slide deck, or like I've also have a whole talk that went through this slide deck as well. Take a pause, because now you're in this situation where like you're trying to keep track of all of this stuff through a for loop, and that's not really the best way that you want to deal with that. So if you end up calling the same component to create a function multiple times, like take a pause. If you're creating a list of IDs and like you're just appending stuff to make a bunch of IDs because IDs have to be unique, also take another pause. That's probably you can slowly start creating more problems for yourself. Maybe you're creating 2 lists and you're trying to zip and like iterate the 2 lists because they're all tied, the information is all traveling together. Don't do that. That is another place where you might want to pause. And then, yes, like iterating across multiple lists to ensure things are captured together, like especially if you're using the zip function. So in our example, we have our filter component. For each column, we're going to do a whole bunch of stuff to figure out what component is in there. What you can do is like maybe you have a list of columns, a list of column types, and a list of filters, and then now you're going to go dynamically generate that part of the UI. If you write code like this, like again, that's one of those things where you might want to be take a pause. The other thing that we've talked about is if you have like in your application, if there's a whole section that has like a bunch of reactive calcs and it's all related to one another, and it doesn't really, like whatever the one output is gets used by the other parts of the application, but everything else, all of those calculations that's happening there, if that doesn't get used anywhere else, that is also another code smell when you end up writing a very large application that you need it a little bit more maintainable. That's something that you're going to have to take another pause. Maybe this is another technique that you'll look into. Dynamically creating IDs, again, if you are iterating through a for loop just so you can have a unique ID, that is something that, again, you don't really want to be able to do, or at least like minimize where you're doing that, because you're probably doing that in order to repeat some part of your dashboard, and then when you're repeating something that is, again, you might need to think about other techniques on how to create these IDs dynamically. Okay, so Shiny modules. They allow us to encapsulate all of the IDs from the inputs and from the UI and the server. And so we can, in our code, use the same ID so everything is working together. And then when we encapsulate it into a module, essentially what it does is it prefixes or suffixes whatever you want to call that module. And then so it becomes a unique name. And again, this is all on the premise of every single component, input component, has to have a unique name. And so when you end up in a situation where you're just trying to generate unique names, Shiny modules is one way where you can say, like, hey, I want to reuse this whole thing again, but I don't want to manually go and recreate all of those IDs. Again, this is where Shiny modules come in. So in our case, we are iterating through all of our columns, and each of our IDs need to be, they're tied to a particular column name, but then if we want to reuse all of this, they need to be also namespaced into one Shiny module name, so nothing is repeated. And so the way we do this is we can take our existing code and we can say create an actual module, and it returns like all of the calculated filters that we're working with. And then in our server, all we have to say is, where is it? I think it's this. Yeah. In our server, all we have to say is like, here's our module, here's our new module like namespace name, and then everything else gets prepended to it. The way we do that is, hold on, give me 1 second. Oh, okay, whoops. Okay, so we have our UI. It's iterating through and capturing all of the components that we need for our particular filter. On the server side, it is exactly the same code. It is the same reactive code that we want, and then we are literally copy and pasting it and setting it as like a module server. So we're encapsulating all of that logic that is doing the filtering in another separate function. And here we can see that, yes, this particular module or this particular function will return a mask that we can then use later on to go and filter our entire data set. And so what this ends up looking like is once you modularize all of your code, you can then just say, here's this module that I want to go, we want to go and call the module. So this is the module that we just created. We want to give it a namespace. So we'll call it module. And what this means that all of the filter IDs will have module, I think like prepended with like 2 underscores. And then that will make it unique if we want to use this whole system again. our module itself needs our penguins data set, so it can go and figure out for each column what type of output that we need. And then we will go and put those individual components somewhere in our UI. And then at the end of the day, our module will return back a filter mask by looking at the mask output of it, and we can use that just as something that we use regular pandas to subset on. And then with that, what you can do is, because now you have two separate functions, one for the server and then a separate, this server function also goes and you can create the UI, corresponding UI component of it. You can take those two pieces and move all of that code into like a helper.py or a module.py. And then what you can do in your application is now say import module.py those two components or those things, and you can just go and reuse them. So it is a way where you can go and take really big complex parts of your application, move it away into another module, a Python module if you need to, and then it'll slowly help simplify your application. The other, yes. Now, the fact that you have a single .py or Python module, what you can then do is create a package for it. And now if you have like a really complex, like, hey, if I feed you this type of data input from this particular type of machine, your module can take that as an input, do all of its calculation, and what that means is the end user can just work with the UI, work with the server. So it's really similar to when I just showed you the query chat example, where it's like you just created the chat example. That's actually like a module, and you just use chat UI, that showed up there, and then the server code was all the chat interactions there. And again, query chat is a Python package that you can install, and you can incorporate that into your Shiny application. Okay, and then so what ends up happening is after you move all of that code out, instead of all of that long code with let's go iterate through each of our columns, for each column go figure out the data type, what you end up having is creating the server, putting that stuff in, putting the components where you want in the UI, the server returns a mask, and then you go and deploy the entire, or subset based off that entire application, right? So this code that you see here after the imports is like, that's the entire Shiny app. Right? Like up here, that is like, okay, I'm loading some stuff up, but all of that reactive logic is now hidden away into another file, and I'm just using that here in my application. So if you end up in a situation where your Shiny application is becoming like 1,000, 5,000, 10,000 lines long, figure out the parts that are completely tied together, and then turn them into a module if that's, if there's a bunch of related reactive calculations happening. The last thing that you can do, and really what you want to be able to do with the Shiny module, is reuse it. So if you look at if you remember the example I talked about, like, hey, I wanted like the comparison, like a product. What you can do is now you can reuse that entire module. So for example, if I wanted another tab that had the same penguins thing, these two things look the same, and it's because if I turn one into a module, I can actually have another thing just repeated again. And I think the code for that literally looks like penguins 1, penguins 2, that's the data set, and then the module form looks like, here's the Shiny code for module 1, and I've already done all the logic with setting up all of that UI and all of that server code. So I just need to recall that module again, give it another namespace, and then I can have those two tabs without having to or copy paste the same exact logic, just so I can change the ID because the IDs need to be unique in a Shiny application. Okay, we are actually now approaching time. The last topic, the very, very, very last topic for today is once you have a Shiny app, you might end up in a situation where I've realized the slides never rendered, so I am just going to show you the text in the slide for time. Another thing that you might end up wanting to do is writing essentially a unit test for your application. One thing that you can do is, instead of writing a unit test for your Shiny application, if you have a function that does a calculation, do the Python packaging technique of writing a unit test for that particular function. You can totally do that outside of Shiny. That is nothing special to Shiny itself. So if I'm saying like, hey, I have these 3 things, and I want to get the intersection for all of them, you write a series of assert statements that just say, this is what I calculated, this is what I expect. Write regular unit tests. You can look at the PyOpenSci packaging guidelines for like how to write a unit test. Follow those, and you can use that same exact technique in your Shiny applications. Another way you can test your Shiny applications, we'll get rid of that to-do. Another way we can use that test our Shiny applications is actually trying to mimic like a user clicking through certain aspects of it. So in Shiny, it comes with some Shiny-specific support functions that's built on top of Playwright. And Playwright is one of the tools that Python gives you just to interact with a web browser through Python. It's in some sense similar to Selenium, except it's like the more modern way that you would be interacting with a website. And so if you have a Shiny app, the way you would work and test your Shiny app is you first create the actual Shiny app for it to load up in this imaginary browser. And then you write a series of test functions. And all you're doing is saying like, hey, I have this input component called input selectize. I want to access like that particular component. I want it to set it to a particular value, and then when I set it to a particular value, so for a input selectize, it's probably like a box with like one of the values filled in. I expect that to be just a list of one object called Friday. Or if you have another component, you can say, okay, now I want like an object that refers to another part of my application. And when I have selected Friday, I also only expect like the only options available are now just dinner, right? So you can programmatically interact with an application by changing the components and their values. You have access to work with that. And this is another way where you can test your actual Shiny applications. Which is, the more you look at this code, for me, it was just like, oh, that's actually like kind of nice. If you squint your eyes, like it makes a lot of sense. So in this particular application, it's testing one thing. It's testing one set of behaviors, which is I make a selection on a selectize object, and then I'm checking the contents of another. You could do the same thing with maybe you're making a bunch of different selections, because maybe you're trying to maybe you just wrote some code that handles the scenario where if the user selects a bunch of stuff, the data frame becomes null and it errors and everything else happens. And you just wrote some code that says like when the data frame is empty, just show an empty data frame. Like don't just like error. Maybe just for all of the other output components show like a 0 or something. Don't just like error and show red text. If that's something you just implemented and you know the sequence of clicks to make that happen, you can programmatically make those sequence of clicks happen and then check that what you expect in one of your cards or your value boxes or your data frame is actually what your fix just tried to do. All right, it is 5 o'clock, and the entire Shiny team is right behind you. So they are going to come up to the stage, and we will open up our Slido. This is recorded, so please write like a question that is like nice, or like follows like some type of code of conduct guideline. And I think this is, that's not that many questions. So I think we can, if anyone actually has a question, you can raise your hand before we go through Slido. I just thought it would be easier if we queued up a few questions, but we can bring up the entire Shiny engineering team, and they can introduce themselves if they want, and you can ask them any question that I was not able to answer today, which wasn't that many. So. You can start from the top. Would you take this? I think there's a camera, so you might want to stand roughly where I'm standing.
We'll take turns.
So hi, I'm Carson, engineer on the Shiny team. I think close to 7 years now. And then we're just taking the top one here.
And they also know that you created Chalice, and they had that whole entire demo.
Cool.
So if you have a question about the LLM stuff, this is your guy.
Yeah, thanks. So the first one is, I know there are two PyShiny APIs, Core and Express. Does an app need to be entirely one or the other, or can these API calls get mixed? So there's actually parts of the Shiny API that are kind of intentionally power both of the modes. So if you look at, say, an Express app, you'll notice probably there's an import that looks like shiny.express, import UI. That means that this namespace that you're importing from Express is kind of exclusive to Express mode. So most of the things in there, if not everything, is designed to work just for Express. But even in an Express app, you might see imports kind of from the top level of Shiny. So a lot of Express apps, you'll also see something like from Shiny import reactive. And that's kind of a signal that this thing that I'm importing from the top level of Shiny actually works the same way, regardless of whether you're in Core or Express mode. So that might kind of raise the question, how do I know whether I'm working in one mode or the other? Just kind of the simple, basic way of being able to tell is whether your app has an import from Express at all, then you know that you're working with an Express app. But if it doesn't contain an import from Express, then you're not. You're using Shiny Core. So yeah.
I think next one's for Barry.
It's not data frames. It's just like, how do you make a plot?
You can talk about the data frame part.
Okay, yeah, so are there any up-to-date references on how to plot IBIS or narwhals tables using Shiny? Oh, I missed the tables. I saw plot. My bad. I'm failing to replicate what that website does. Yes, so the render data frame output should work with any narwhals friendly data frame. So I believe narwhals will call them lazy data frames. It doesn't work with lazy data frames, it only works with eager. But if it's narwhal friendly, then it will work with render data frame, which is awesome. I'm sorry to hear that the blog post demo isn't working. So if you're the anonymous, please come see me. I'd love to help. Yeah, but same with plotting. You'll have to most likely realize that data. You can't have it be external somewhere else. You'll have to get it close to the Shiny instance at some point. And then from there, it's just your standard data frame manipulations. But yeah, I think that was like a couple iterations ago, a couple versions ago, that narwhals was just added in for the render data frame, and it just works out of the box. Okay, yeah. I have a process that's going to be expensive to run. Is there a way to have a button that basically says, don't do anything until I press this button? Is there a way to have a... Yeah, don't do anything until the button's done?
Yeah, as of today, the way you would do this kind of thing is, I don't know if in the workshop you came across the reactive event decorator. No.
They saw a button, but it wasn't hooked up.
Okay. So, but you probably covered reactive effects, right?
Just reactive
Okay. So reactive calculations, you know, you're reading a reactive value, and every time that reactive value changes, that triggers the reactive calculation to run. So the idea with the calculation is you have some reactive value that you depend on, and then you return a reactive value from this calculation. The other kind of main way of having a reactive calculation, in a sense, is not necessarily returning a value, but just performing an action or a side effect. So there's another decorator called reactive effect that you use to decorate a function. And you know, this function can then read reactive values, like it can read an input value. And every time that value changes, this reactive effect or this function will re-execute every time the reactive dependencies change. So with a reactive effect, you know, again, you're kind of performing side effects, but you know, the idea, I'm kind of, you can also use this, well, let me just say with reactive event, it's a way of saying don't actually run this calculation or this reactive effect until just this particular input value changes. So basically ignore changes from anything else inside of this function, but just re-execute when this particular thing changes. So the pattern that you typically see with this is, you know, you have a button that you give an input, say it's, you know, the ID is BTN or something like that, and then you would have this reactive event decorator to say only invalidate this calculation or this effect whenever this button gets pressed. The reason why I kind of wanted to take this one is I actually have a piece of work in progress that would allow you to basically kind of plop a button anywhere on the page. If you've ever programmed in R-Shiny before, there's a submit button component where you can just plop it on a page, and it says basically don't listen to any changes in input values until this button gets pressed. So it's a way of saying like delay any reactivity until this button gets pressed. And there's a piece of work in progress to kind of bring the same idea, but in a sort of more, a little bit more advanced way for both Python and R. Maybe this would be a good one for Joe.
Just following on to that one, basically?
No, just extended tasks.
Right. Is there a question? Was there a separate question about extended tasks, or just to talk about it?
Just like an extension of that.
Hi, I'm Joe Chen. I've been with Posit for 16 years. I think one of the things that's interesting about using reactive.event with these long-running tasks is it does save you from, you know, you've changed these values, you weren't ready for it to execute, but it started executing anyway. Reactive event does solve that problem. It lets you delay until you hit a button. But there's another couple of problems that it doesn't save you from, which is what happens while that calculation is happening. If that calculation is like 3 seconds, no big deal. If that calculation is like 30 seconds, then by default, the entire user session is just kind of blocked while that calculation proceeds. You can like click buttons, you can change values, but none of them are actually going to have any effect on the server until it's done with all of the reactive stuff that it was already busy doing. Often that's okay, or at least intuitive to the user. Sometimes you want to kick off something and let the user continue to use the app. Like for example, if the thing that is happening is like, take the current state of the app and kick off some kind of long-running report or something like that, and meanwhile, I'll start working on the next one. That might be an example of something where, like, I want to fire off this thing and then keep working. So there is a feature called extended task that is designed for that. So you basically take your long-running code and put it inside of this special type of object, and if you do it that way, then when you hit that go button, the whole app stays live. And then you can also there's instructions in the documentation of how to react appropriately when that long-running operation, when that extended task completes. Can logs be streamed to the front end? That's a good idea. Not right now. Wednesday. There we go. Shiny validate. What's it? So how to communicate a user input error to, I really want to avoid it being me just standing up here answering one question after another, but so by default in Shiny, the easiest way is that wherever you are using this, this text input, wherever you're using that, just throw an error. So if you do that, the right thing will happen. Anything that depends on if you're in a reactive calc, anything that depends on that reactive calc will display an error in the UI somewhere. However, that's maybe not the nicest user experience, right? Like you typed in an input here and then like a bunch of plots turned into error messages. Like that might get the point across, but it's not great. So there is another package called Shiny Validate that was written by a former member of this team, where you can basically set up a set of rules for each input, and if those rules are violated, then an error shows up right next, well, just what you expect when you're filling out a form online and there's a mistake. It does the validation at the site of the input, and then all of your downstream calculations can check whether validation passed, and if not, then you can just stop and show a blank screen or something. So that's called Shiny Validate, one word.
Just talked about those. I don't know if there's anything specific required.
Is there other ways that they're talking about also like extracting all the stuff into modules and using PyTest?
I mean, the quick answer is no. There's no.
Okay, so you guys saw Playwright, right? Daniel demonstrated Playwright. So it is also, I think, a really good idea that when you're building a Shiny app to extract out all of the logic that is not Shiny specific or Shiny related. So if there are like complicated transformations that you're doing to your data, if there are complicated plots that you need to create, if there are models that you need to load and apply, consider making a separate module, a separate .py file, and put all of your functions in there, and just have them take things like data frames as input, have them take variables as input. That way, you can test them entirely separate from your Shiny app. So your Shiny app.py becomes mostly UI and things that hook up UI to calls to these functions. Therefore, you can test the functions in isolation. That makes it much easier. You can test them interactively from a Jupyter Notebook or from the IPython console. So you can work much more quickly and iteratively. You can use the Python debugger. And if you really want to, you can also write a suite of unit tests using the PyTest framework. As far as testing it once it is inside of an application, then, and testing it from end to end, including all the Shiny code, yeah, Playwright is the way to go. For all these questions, if we haven't answered your question, can you please just raise your hand and ask a follow-up, please?
That was the last one on slide. I don't know if anyone else has that.
What's the best way to deploy Shiny app on, say, a remote server?
I forgot to show that.
Yeah, the question was how to what's the best way to deploy a Shiny app to a remote server?
There is a slide deck for using Connect Cloud that I hope show you for time. It's in that section. Oh yeah. So in the course materials for today, one of the things that I realized for time and other reasons, totally forgot to show you, which is there is a slide deck on. Oh, that's why it didn't render. Okay, there will be a slide deck on deploying your application. It uses one of the services that we host at Posit called Connect Cloud. And as long as you have your Shiny application in a GitHub repository, you can log into Connect Cloud, point it to your repository, and if by default it's looking for an app.py file, and once it finds the app.py file, it will install all the requirements from a requirements.txt and Shiny run application on that server, and you can deploy it that way. As far as, I don't know what the actual resource limitations are in that sense. Technically you can also pay us, Posit, if you need more space or if you need a private repository or something like that, you can totally do that as well. But that's one way where you can deploy a Shiny application. For a workshop like this, or if you're trying to prototype something, I would say Connect Cloud is built for that. Oh yeah, they have seen Shiny live. Yeah. Yeah, so the other way, if you can make it really simple, do it on Shiny Live, and then you don't have to worry at all about the end user having anything set up. I don't know if anyone has recommendations on I don't know, having a Heroku server and just Dockerizing everything. I don't know if you have comments, questions around that, or how to deploy stuff that way.
Yeah, one thing that people have done also is just to take their Python process and throw it in a container and put that somewhere, and put it on generic Python services like Heroku. I have heard mixed reports about whether this works well. It will work initially for sure. The one thing that I will warn you is that there are certain features in Shiny that require. Normally, it's just a WebSocket connection between the browser and the server, and then there are some features that also will add AJAX callbacks to that. So not only are they communicating over the WebSockets, but they're also communicating over additional AJAX calls, HTTP calls. In some of these environments, there might be multiple Python processes in the back end, and the hosting service might not be smart enough to always route the HTTP calls to the matching Python process that's already serving up the WebSocket. So it'll start looking for sessions that aren't there. If you find yourself in this situation, please reach out to us and we can help you figure it out. But there is the Connect Cloud service. If that works for you, awesome. If you want to host it on your own infrastructure, we do have an open source server called Shiny Server that's written in Node.js that is designed for hosting these in a safer way. If the Python process goes down for whatever reason, it will be brought back up. There's logging and things like that. If you work at a big organization or part of a educational institution, we also have an on-prem like an on-prem Heroku for Shiny, basically. It's called Posit Connect. And that basically lets you do push-button deployment from your local machine, and it'll just go to your local Connect server and do the same kind of deployment that Connect Cloud would do. So, does that answer the question? Okay, cool.
All right, I want to add one more thing about Shiny Live. So you've probably seen these Shiny Live apps where it's running, the Python part is running in the browser, in Pyodide. So normally, like, you can go to shinylive.io, and then if you work on an application there, you'll actually see the whole application encoded in the URL. The URL can be quite long. But there's also a Shiny Live Python package that provides a command line tool. And you can, you can say, what is it, Shiny Live export, this is from a terminal, Shiny Live export, and then the path to your app, and it will generate a bundle where there's like a static HTML file and all the other files you need to load that application and serve it statically. So you can just put it on a static web server, like GitHub Pages, for example. But this only works well for the the class of apps where you can run it completely in the browser. So you don't have like most network connectivity. You don't want to put any private data in there, things like that. But you can serve these types of apps from a static web server with the Shiny Live command line tool. Yeah. Anyone want to take this? I mean, I feel like we're pretty biased in the world that we live in and we work in. It's like, okay, we're going to use Shiny for all the stuff that we do. So I can speak to this. Okay, yeah.
So I think that BI is one of the best use cases for Shiny. I mean, in some ways, it's like Shiny is almost a little overpowered for a lot of BI scenarios, but it's one of the places where I think Shiny has resonated the most with people. And I had a conversation with someone that was working at Posit at the time who used to be a consultant, and he said that they would have to do Tableau dashboards. Like, they didn't have a choice. Like, it was the organizational standards. That's what they were going to do. And they would actually prototype in Shiny and then redo it in Tableau. And I thought, like, that's totally backwards, because, like, for all the things that Shiny does well, surely, like, pointing and clicking your way through a Tableau dashboard, that's got to be easier and faster than writing, Python code or R code. And he made a couple of points. He said, number one, like, that might be true the first time, but if you're making a bunch of similar, BI dashboards that vary only in like a few key ways, for a lot of these BI platforms that you're kind of pointing and clicking your way through designing these dashboards, the ability to reuse logic, the ability to reuse building blocks that you've done before is very difficult. Like, even like the ability to like do exactly the same visualizations, but now you have a totally different data set that you're using. It's like, all right, new dashboard or whatever. So that was one aspect of it. And then a second one was that like when you're on your 10th BI dashboard, like, it's just not that fun anymore, when you're like pointing and clicking your way through. Whereas with Shiny, like, the more you do it, like, the faster you get. And then the third, which is a little bit cynical, but like the third was like, it just felt like being able to do these things in code felt like a leveling up professionally in a way that, like, I made another Power BI dashboard didn't. That being said, I think less cynically, I'm told there are frequently things that, like, you want from your BI dashboard where Power BI can do 98% of it. But then that one last thing, like, you can't do. You completely have to switch to another system. Like, for example, like, you're using a dashboard to look at, live-ish metrics and you're looking for outliers. Like outliers in response time, outliers in inventory levels, whatever it is. And then when you see something, what happens? And with a Shiny dashboard, you might be able to say, it'd be really convenient if, like, right here while I'm looking at it, I can click on the thing that looks suspicious and I can make a note and I hit OK, and that kicks off like a workflow that results in the right people being notified and something going into a database. It's like with Shiny, it's like, sure, if you feel like adding that, you can add that. And with things like Tableau and Power BI, it's more like, okay, now you're like, go write a React app, and that's a different department that does that. So yeah, for BI type scenarios, I generally wouldn't hesitate. And really, the main thing that those BI tools do much better is the set of people who can build them is larger than the set of people who can write Python.
You mentioned something with Shiny Live, basically don't put sensitive data on it. Can you go a little bit into the threat level? Like, if I wanted to make something where a user can supply an API key, which would be private to them, is that a concern, or is that something that should be done?
Yeah. All right, so for a Shiny Live application, all of the code and all of the data gets sent to the user's web browser. So they can look at all that stuff. So if you have any sensitive data that you want to use in your application, that's not a good way to do it, because it's going to be sent to their web browser. I mean, maybe you can aggregate it or summarize it beforehand, and that's okay. For the specific question you had about API keys, you can have the user enter an API key. And as long as you're not, that's not you exposing your secrets. That's them providing their secret to this application. So that's fine. And if you want to get to do a little bit of JavaScript code, you could probably save that in like their browser local storage too, so they only have to enter it once. So yeah, that's doable. Oh yeah. So so Joe brought up something. Is your API key likely to work? Are you going to be able to actually talk to that API? Sometimes you can, and sometimes you can't. There's security restrictions that make it so you can't send all types of HTTP requests from a web browser. There's like CORS issues. There's some Python libraries. Well, most Python libraries for HTTP requests will not work in PyDide in the browser, but some of them are patched so that they can work. Which one is it? Like request something 3? What is it? Yeah, Seaborn. There's some shims that let you make these requests from the web browser using like normal standard APIs, but you have to find the right one, and then there might be like these CORS browser security restrictions that prevent you from actually making requests to a particular API endpoint. So yeah, yeah. So it might work, it might not.
Yeah, and then with the concept of like storing secrets, that's when you really look into some of those like hosted services. Like for example, Connect Cloud, there is in the web interface a way to provide a key, and then similar to like secrets that GitHub gives you a personal access token, like once you enter it, like it's like you can't see it again, but it's stored there. And then you can use your the Python code to like pick up environment variables and just load it in that way. So it depends on if you are providing the key or you are asking the user to provide their own key. If you're asking the user, then you can do something like with a text box input and like maybe put a Shiny validate in there to make sure like it begins with the right letters or something like that. Otherwise, yeah, you're looking at something that's hosted, and then depending on your server needs, like that hosted server, you might have to pay for it or not, yes or no. But in Connect Cloud, if your application is on GitHub and you deploy it and you need to store secrets, there is a way to store secrets along with your application that is hidden from the user or anyone else who's trying to access it. We got one more. Yes.
Yes, that is correct. Oh, sorry. Shiny is single process, single thread. That's true. I mean, if you want, you can use async, and you can use multiprocessing inside of a reactive, as a synchronous or asynchronous thing. But yes, in general, the entire reactive loop, basically, with the one exception of extended task, is the only thing that will completely make it async relative to everything else. Everything else is serialized in one thread of execution. Currently, that's even true of if you have multiple sessions. Multiple sessions are all also serialized on a single thread. And that is something that we are thinking about lifting that restriction. But right now, that's how it works. Oh, yes. So some of the server hosting platforms that we have, like Connect Cloud and Posit Connect, will automatically scale up to multiple processes at least. So you do have per process scaling. And you can say, like, for each process, how many users can it support? So if you know your application is very slow and CPU intensive, maybe it's like, as few as 1 or 2 or 3 users per process before it should spawn a new one. Yeah. Oh, does the UI update as the functions finish? By and large, mostly it waits for them all to be ready. So this is I think a little bit of a controversial decision that I made in the early days of Shiny, that as soon as you change a value or click a button or whatever, everything that needs to be changed slightly fades out or shows a spinner or whatever. And the controversial part is that not until every single one of those outputs is ready do they all get pushed at once. And that was just like, at the time, I felt like it looked weird and confusing for these things to come in like one at a time. But I do admit, like, there are definitely cases where you've got like 3 fast things and 1 really slow thing, and it would be nice to see things in progress. So that's definitely something we could look into making an option or something in the future.
Great. Cool. That's the time. That's the end of the workshop. Thank you, everyone, for coming, especially sticking around for the last 30 minutes for the Q&A portion. I owe you a couple of stuff on this particular website. So there's a missing slide deck, and I realized that like some of those decks on the website are 404ing, but they're clearly they render just fine. So I have to go and figure out like what is causing that. The other thing is, like I said, there was like that exercise of like trying to get the button to work that we sort of skipped over, and it ended up being one of the questions. So our dashboarding app, I'll provide the solution for like the reset button app, and then that ties together with the just how buttons work, and then that is the answer to like how do I wait for everything to happen until a button gets clicked. So I'll provide some follow-up, it'll update in Slack, and then you'll have all of the materials that we talked about today just forever until GitHub turns off, which I doubt will happen. So thank you everyone for coming. Oh yeah. So that's the end of the tutorial session. We, as Posit, we do have a booth, which I believe all the booths are right outside. So feel free to come with your Shiny application questions, or if you're prototyping something this week, feel free to just drop by the booth and someone here will be able to talk you through it. I am also staying for the first morning of sprints on Saturday, so you'll have an opportunity to we can work on something then, or if you have a question about chatless and getting all of that hooked up, that is also what my actual sprint topic is about, but it's open to anything we talked about today. So we're here for the week. Find us. It should be pretty easy to find us. Just go to the booth, and you've already seen what we all look like, so it'll be great. All right, thank you.